We are live. Welcome, welcome. Howdy, howdy, everybody. Hope everybody can hear me just fine, and I hope everybody's having a good, super early. Oh, you're early. Hope everybody's having a good Tuesday? Is today Tuesday? Sounds like it's Tuesday. Yeah, it feels like a Tuesday. Unfortunate indeed. Well, you guys know what to do. So if you have your questions, which, you know, totally reasonable if you do, if you have questions, you can either just ask them in the chat, whether you're on TikTok, Twitch, YouTube, vertical, YouTube horizontal, or if you want to guarantee that your questions get answered, or at least that I see them and I address them, I might not know the answer, you can send a super chat. So that's how we do this. Make sure that you ask your questions. I will be bringing up guests in an hour and a half to ask questions, you know, verbally in person. But that won't be for another hour and a half, and then the live chat will be closed to, well, it won't be closed, but the only chats that we'll get through will be from fans, subscribers, whatever the $4 or $5 a month thing is. Can I go to college for math and get into research on physics later? You can, but you will be lacking a lot of the physics stuff that you need. So like it does, you know, there's a reason why people go into physics if they want to do physics research, but yeah, it's not impossible. Do laws of physics precede the quarks? If so, what caused the laws? I don't think that the laws of physics have that kind of ontology that quarks do. In your opinion, why does the universe follow mathematical laws? Well, I think that the universe has certain dispositions, and the things within the universe have certain dispositions, and we came up with mathematical laws to describe those dispositions. Is a physicist's salary enough to get a decent haircut? Sure. Well, but my hair's just tied back, that's all. Right. Can dark matter just be highly dense and compressed vacuum energy? No. You can't compress vacuum energy. Can time be viewed as information instead of a dimension? I haven't seen a way to do this, no. What happens if two objects traveling towards each other at 0.75 the speed of light? Aren't they meeting at 1.5 light speed? No. So what is true is that the gap between them is shrinking, and it's shrinking at a particular rate from a, you know, some observer's perspective, and that rate will get smaller at 1.5 C. But that's not anything moving at 1.5 C from anybody's perspective. For example, from the perspective of one of the people moving at 0.75 C, you could calculate what the perspective is, or how fast the other one appears to be approaching them. There's something called the relativistic velocity formula, which is it's the sum of the speeds divided by square root of, or divided by 1 plus uv over c squared, which I can't do in my head, so I'm going to pull up a calculator and we can get you the number. Because it'll be easier that way. 0.75. 0.75, so they will approach each other at 0.96 times the speed of light, or from each other's perspective. You see Dr. Oz might replace RFK. I haven't had lettuce in weeks. Ooh, that's rough. Would that be better or worse? Could shamanism explain extra dimensions? I don't think so. Why don't the electrons just leave and get a job? Good point. How does your expertise in physics inform your understanding of philosophy? Does it afford unique perspectives? I mean, I don't know. I think it's probably more that... I actually think that it's probably my mathematical training that probably informs my understanding of philosophy more, because I have a good grasp of analytic philosophy just kind of by having a math degree. Is there a strong consensus around heat death of the universe versus Big Crunch? Are there any upcoming experiments that would help firm this up? No upcoming experiments, but observational data from the, what's it called? The Vera Rubin telescope should probably help. The consensus is probably still around heat death, but I suspect that it's probably less strong than it used to be. What are your thoughts on the many worlds interpretation? I still like it. I like the many worlds interpretation. Do you like Wolfram and his thoughts on his physics project? No, I don't really like Wolfram. I don't have any particularly important thoughts about his physics either. Would it be accurate to say the laws of physics are just the observable properties of stuff? Yeah, I think so. From physics, what is your opinion on free will? Well, physics would seem to imply that there isn't any. Can you explain eternal inflation? Yeah, the idea is that the universe outside of the observable universe, and probably far outside, like the matter-filled universe that we're living in, is basically empty and filled with essentially a very, very high energy version of dark energy. And that's causing this empty universe to just expand extraordinarily quickly. But sometimes in localized places, that high energy, dark energy will kind of quantum tunnel down, or it'll roll down. There's a few different ways to interpret it, but it'll basically drop energy and create a big bang at some random place. And so you'll just get, this will be happening forever. What do you think about the AI counterexample to the Jacobian conjecture? It's neat, I guess. Why is there so much energy in atoms? They're microscopic, but they're essential to nuclear devices. So it's not that there's a lot of energy in atoms. It's just that there are a lot of atoms, and there's some energy in every atom. That's kind of the way to think about it. How would you define quantum fluctuations outside of space, time, and matter? I wouldn't. I mean, you can talk about quantum fluctuations of like pre-geometric space-times, but like that's still kind of space-time. Isn't Dr. Oz a good surgeon though? Yeah, but you can be a good surgeon and still be an idiot. Would it be possible to break the bottleneck of space travel? Light year almost seems imaginable. Probably not. I have to jump down to the bottom because I'm way behind. Apologies if I missed your question. How did you verify Earth's assumed radius in reality? Because with sticks and shadows, we must assume curvature before measuring the shadows. No, the point is that you can test two hypotheses. If the Earth is flat, then there's no curvature, and you can compare the outcomes of stick experiments with the predictions of a flat Earth. Or your hypothesis can be that the Earth is a sphere, and then compare the outcomes of the experiment with the predictions made by the sphere, and you find that the outcomes of the experiment match with the predictions made by the sphere model and don't match with the predictions made by the flat model. But more than that, I mean, there are ways that you can measure the curvature of the Earth directly by using things like reciprocal zenith angles. But to be clear, you can't really talk about a radius until you know that it's a sphere, right? And we can know it's a sphere from doing like reciprocal zenith angle measurements, or from like doing the Eratosthenes type experiment, all these things. How do we know electromagnetic fields exist? Because we can measure them. We can measure them with voltmeters, for example. Why are there 4 fundamental forces, not more, not less? That's not a question for a physicist. That's like, this is not the kind of question that physics is like. Physics answers questions of how, not why, generally. Element 115, do you think in its stable form it might have the ability to manipulate gravity? There probably is no stable form of element 115. There's no evidence that it has any stable form. What is spacetime, and why does mass have an impact on it? Spacetime is the places and the times. It's the wheres and the whens. And why does mass have an impact on it? It seems that that's just a feature of our reality. What specifically did you do your PhD in? I did my PhD in something called conformal hypersurface geometry with an application towards the ADS-CFT correspondence. How do you feel about the future of Earth in terms of climate change war? I feel negatively. Is the early universe cosmology a good research field? I think it's interesting. Did you get a math and physics degree, or was either of them a post-grad program? I did a bachelor's in mathematics and a bachelor's in physics, and then I did a master's and a PhD in physics. But my bachelor's or my PhD in physics was also very mathy, so. You can measure the curvature of the Earth with sticks. He built it in a cave! Hey Haley, it's good to see you. The speed of light is a limit. How does that work with the expanding universe? the speed of light is a local limit, meaning that like if something is right next to you, you will never. It is impossible for it to be traveling next to you at the speed of, or faster than the speed of light. But the speed of light is not a global limit. There's not even a good way to define speeds if you're talking about something very far away moving. There's not some kind of the phrase would be there's not like some invariant way of describing the speed in a coordinate invariant way. Why is most of the mass of normal matter just massless? Is the gluons? Makes no sense to me. Well, it's not necessarily the gluons, it's the gluon field. The gluon field and the gluon field and the quark fields make up a bit the potential energy of the gluon field and the kinetic energy of the quark fields make up a big chunk of the mass of quarks because they're very, very tightly bound together. How well do you know Jackson's E&M? You must know MHD and plasma physics to debate the Big Bang. I took a class using Jackson's E&M. It was horrible. I hate that book, but we all have to go through it. Love your content. I would love to get into physics. What books do you recommend for beginners? Pick up a book like A Brief History of Time. It's a good way to get a taste for the kind of physics that I care about. Is space-time a part of the universe or vice versa? I would say that space-time plus all the fields on top of it is the universe. Measuring reciprocal zeniths also require you to assume curvature in the first instance, just like sticks and shadows. No, it doesn't. You can just measure them. You can just measure reciprocal zenith angles, and then once you measure them, you see that they don't add up to 180, which means that we don't live on a flat surface. Isn't that what your diagram shows for the beginning of the universe, quantum fluctuations? Yeah, but it's just a diagram. Like, it's just one possible story, and that's the story that Alexander Blankin believes, but I don't believe it. How can a singularity have infinite density? Well, that's part of what makes it a singularity, right? I'm going to jump down to the bottom because I'm way behind, but thank you guys for asking so many good questions. And remember, if you want to guarantee that your question gets answered, because sometimes I have to skip them, make sure to send a super chat. It's a good way to support me, and it's a good way to get your question answered. If you're a physicist, do you study physics? In a sense, I mean, it means that I do research, and I do research in physics. Like, that's part of my occupation. Isn't speed relative to the observer? Nothing cannot move. Well, the observer is not moving relative to the observer. This may be a category error, but how do photons experience move through time? Well, so they do move through time, no problem. Like, they're at different moments of time in space-time, different time slices, if you will. They don't experience anything because obviously they're not sentient. But they don't even have, even though they're not sentient, you can imagine that, like, you know, you could say, like, what does a rocket experience? But the point is that in order to talk about what a rocket would experience, what this means is something like if you put a clock on the rocket, what would it do? And so in order to figure that out, you have to do something called a Lorentz transformation. And a Lorentz transformation is the way that you kind of you kind of move your perspective from being stationary to being moving, for example. But there is no valid Lorentz transformation that takes you into a photon's frame of reference. So photons don't have a frame of reference. So they don't have an experience of time. It's a category error, like you said. What's something you wished more of your colors knew understood? I wish they knew anything about physics. Just like anything. Anything would be good. Do you think the inflaton field exists? I think it's possible that there's some kind of field that could be like a scalar field, for example. Which is what the inflaton would be. So your diagram for the universe has quantum fluctuations as a beginning point, yet you can't define them, so you just grant yourself something. No, I don't think that quantum fluctuations are like the real thing that explains why the universe exists. That's what Alexander Blankin thinks. They can absolutely be defined. I think that you're a little bit confused. Do space-time and matter have to come into existence at the same time? No. In fact, that's not even possible because time can't come into existence at a time. What university did you go to? I got my PhD from UC Davis. I may be misremembering, but I thought at some point you mentioned there's a valid theory or suspicion that there could be a first moment in time. If that's true, how does that rationalize with the temporal criticism Ian makes? Ian's criticism is a criticism that only makes sense in the A theory of time. Most physicists who are talking about early universe cosmology or the beginning of the universe, if there was such a thing, are implicitly assuming a B theory. So there's no contradiction there. Ian's criticism is more of a criticism of A theory than it is a criticism of the first moment of time. But he'll never tell you that. They'll never tell you that. God, I'm such a bad friend. Do you agree that mathematics is the source code and physics is just an application of mathematics? No, I don't think mathematics is a source code. Are there possible quantum fields that we can never detect or interact with? I mean, it's possible, yeah. So he just uses a diagram he doesn't believe? Yeah, it's a pretty good diagram. I don't hold a strong belief about the origin of the universe to begin with. So, like, what diagram am I supposed to use? Just like put a big question mark? Like, no, I'm going to use a diagram. just sounds like you want to tone police. What's the real difference between studying and researching? Studying is often, so it's a small difference, but researching also includes doing unique or coming up with unique ideas that you can't find in a book or a paper. So you're a physician? No, physicist. Do we know what causes degeneracy pressure of the Pauli exclusion principle? Because to me it seems like a purely mathematical proof that two fermions occupying the same states leads to an invalid state. Well, it seems like purely mathematical proof. Well, yeah, I mean, the point is if you can prove something mathematical and the hypotheses are physically true, then the conclusions must follow. The reason why there's degeneracy pressure is because two fermions can't occupy the same state, and if they because of that, they have to have higher kinetic energy in order to not occupy the same state. They must be distributed into higher energy shells. Sorry if stupid question, no stupid questions, but I don't understand vacuum decay. Does that require trigger? One sec, sorry. So vacuum decay could require a trigger, but it's more like that it requires kind of a fluctuation that would cause it to happen. So think of it like our universe is sitting at the bottom of a well, and we're happy at the bottom of the well, but so think of like the well as like big cup, but at the edge of the cup you could roll down and be at even lower energy. We just don't have enough energy to go over the hill and then down into the lower energy state. But if a quantum fluctuation could allow you, or if you could tunnel through that barrier because you don't have enough energy normally, then you could go down to a lower energy state, and that would be a vacuum decay. There's been more attention given to the theory that we're inside a giant black hole. No, there really hasn't. How do you ask a physicist? You type a question into the chat. I'm going to jump down to the bottom again because I'm missing some questions, because I'm missing a lot. But feel free to continue asking your questions, and I'll do my best to keep answering them. Also, I think researching is more of a writing process than a studying process. Well, it can be, but there's a lot of reading involved and a lot of studying involved and learning involved. Why do physicists deny God? Well, some do. Probably most do, or at least about half do. But for the most part, it's because physicists tend to be empirically minded people, perhaps. Have the federal funding cuts affected your research? No. Do we live in a flat universe? Yes or no? Explain why. So by flat, so the evidence says it's likely that we live in a flat universe, where flat means something like there is no spatial curvature. At each moment of time, there is no spatial curvature. Now that doesn't mean that it's two-dimensional. What it means is that in some sense, like the intrinsic curvature of the universe, if you took away all the matter, would have a certain, would be zero. There'd be no intrinsic curvature. Whereas you could have, even if you took away all the matter, you could have a universe that has intrinsic curvature anyway. Can you do a small explanation on loop quantum cosmology? Sorry if a bit silly. Loop quantum cosmology is not so well developed, but one of the key predictions of loop quantum cosmology that I use, I don't know a lot more beyond this, but one of the key predictions of loop quantum cosmology is that there is kind of a maximum energy density that space-time can permit. You can't get to a higher energy density than that. So instead of having a singularity 13.8 billion years ago, you would have a very hard dense core, like the universe would reach a certain density and then we kind of bounce off of it. And so that would be an interesting consequence of loop quantum gravity. Now, how they derive that is a bit complicated, but that's one of the more useful features. What are 5 major discoveries have come from CERN? So it depends on what you consider major, I guess, but CERN discovered the Higgs, in the last 15 years, CERN discovered the Higgs boson, tetraquarks, pentaquarks, and I think that that's what they discovered in the last 15 years. But it's not just about discovering new things, it's about measuring new things with better precision. And then I think that they discovered some of the other quarks, some of the quarks in the like in the early days before the LHC turned on, but the LHC was designed to discover the Higgs boson. Do I make posters? I don't know what that means. I've made posters for talks or for conferences. I made one 2 weeks ago. Can you explain how Riemannian geometry and manifolds are used in general relativity? Well, general relativity posits that our universe, or that space-time, rather, is a 4-dimensional manifold. It's just not a Riemannian manifold, it's a Lorentzian manifold, which is a generalization of the Riemannian manifold. So I mean, all of this stuff like Riemann curvature tensors, Ricci tensors, scalar curvature, geodesics, caustics, all of these things, these are all imported from Riemannian geometry. Did you see the lumpy oblate spheroid NASA releasing imaging of? No, I didn't. From Garain with the $10, thank you for the super chat, bud. When matter curves spacetime, what's it curving into? Does this mean there's a fourth spatial dimension, like a 2D paper net? A 2D paper needs to exist in 3D spaces in order to bend. So, sorry, I feel like I have to sneeze. I hate sneezing. Okay, right, so this is a good question. It's asked a lot, so hopefully I can clear things up. So there is a way that you can talk, yeah, what's serious wind up? There is a way that you can talk about curvature in this sort of extrinsic sense, and we talk about a thing curving into another dimension, like a sheet of paper curving into a third dimension, that kind of thing. But that's extrinsic curvature. Extrinsic curvature and intrinsic curvature are related. Intrinsic curvature is just the geometry of the thing itself, absent how it behaves in some larger space. And intrinsic curvature can exist even without some larger space existing. For example, and the way that we define intrinsic curvature, at least in the Riemannian setting and Lorentzian setting, is the way that intrinsic curvature is defined is, how do I want to define this? Intrinsic curvature is related to the way that distances between points are, measured, or measured is not the right word. Intrinsic curvature can be quantified by looking at how distant different points are from one another. And so you can imagine that there's like a sheet of paper, and for whatever reason, there's just like a part in the middle of the page that it takes a really long time to cross. Like it just has it costs a lot of distance to cross this part of the page. You would say that there's curvature there, and you could capture that by treating it as if there's a big lump there, but that big lump isn't there. It's just that distances are different in that place than in somewhere else. And so if those distances are different, that's how you can talk about curvature. So when we talk about space-time doesn't mean, when you talk about the curvature of space-time, it doesn't mean that there's some higher dimensional thing that it's curving into. What it means is that it has intrinsic curvature. From Stein's Productions, official with the 15 shekels. Hello, can time only exist from a perspective? I don't know exactly what the question means, but look, so as far as physics is concerned, time is one of the 4 dimensions of space-time. It exists whether there's people or not, right? Whether there's perspectives or not. Do you believe the slit experiment applies to all matter energy? Well, you're talking about the double slit, and yes, it does. We've done this with like large molecules. It's just really hard to get coherent quantum states for large systems. From Bu Kot Key with the $5, what's your understanding of the Mandelbrot equation? Can you explain how we are using it today? It's not really a thing that's being used. The Mandelbrot equation is just a chaotic system, if you will. Chaotic's not the right word. A fractal system. It doesn't have any use though. It's just an iterative procedure that you can use to generate a set, and the boundary of that set is a fractal. That's it. I imagine intrinsic curvature like deforming the interior of a sponge. Yeah, you could say that, but even in that sense, it's kind of, yeah, actually, that's actually a pretty good analogy. Yeah, it'd be like dragging a piece of the sponge like around from the inside so that it's not actually changing shape, but like the, kind of the density of sponginess is different in different places. That's a decent analogy. Do you believe there is other intelligent ET life in the universe, and do you think technosignatures are the most likely to provide evidence for it? I do think that there probably is other intelligent ET life in the universe. I don't know if we will ever see it. Why should the general public care about funding fundamental mathematical physics research? Maybe you shouldn't. I mean, look, like if you're not interested in learning how the world works. If you don't think that that's valuable, then maybe you shouldn't care. I think that figuring out and learning how the world works is indeed valuable. Also, for some reason, all of my... Okay, there we go. They're back. But maybe you shouldn't care. From baseless with the 2 pounds, does the universe expand uniformly? Thanks. That's the best model that we have says that it is. Now, whether that's actually true or whether there's some slight, anisotropies, that's a different story. There's some evidence that like the universe is not quite expanding uniformly, but it's very tentative and probably not. I wouldn't go around saying that. I wouldn't say that it's like that we know that that's true. It does seem like it's expanding uniformly, but there's maybe some questionable data that might suggest otherwise. From Victor Weirich, with the 5, what are our dollars? Are those Brazilian reals or Brazilian reais? Brazilian reals, yeah, okay, I always forget. Is energy a physically real entity, or is it simply a mathematical construct we assign to physical systems? What's your criteria for deciding? I say the latter. It's simply a mathematical construct we assign to physical systems because I don't think that numbers exist. That's all. And to be clear, like as far as I'm concerned, something is real if it doesn't care about how you define it. It's just there. Like a star, a star's a real thing. Like it's just an object. It doesn't care what coordinates you use. It doesn't care what unit system you use. But energy is like a very energy is like a number that you can compute for a system in a certain setting. Like it's very. I don't want to say it's vague, but it's not like an objective thing that you can just go out, reach out and touch, right? From C-Bar with the $5, what's the loop in loop quantum gravity and loop cosmology? Are they referring to strings? They are not. They're essentially referring to, so in some sense they've discretized space in a way, and the thing that they're quantizing is kind of loops in space. And these are not strings, these are just kind of like paths that are closed. From Stein, but I don't know a lot about loop quantum cosmology or loop quantum gravity for what it's worth. From Stein's production with the 15 shekels, again, thank you. Does it only apply to humans or any living thing? About time perspective. Time perspective isn't really a thing. Like I thought I explained this earlier. The point is that time is just a thing that exists, at least as far as we can tell. It's a property of a universe that we live in. It's not a matter of perspective. It just exists. Thank you guys so much for the super chats, by the way. I do appreciate them, and they help me justify keeping this this channel going. I don't know why this happens sometimes. That like the YouTube channels just like they just stop showing the questions from YouTube. Okay, it should be good now. Could high-dimensional topology and neural networks somehow relate to high-dimensional structure of physics? I don't think so. Is F equals dp dt an empirical law derived from observation or a definition of force? I would say that it's probably a definition of force. How do you get around the politics of working in academia? Well, I don't work at a university. That's the lovely thing. I don't have to deal with politics. But there is still politics at like conferences and stuff like that. And you just have to be delicate. That's all. For example, I was helping out a new postdoc on a project that he was working on. And the project was sort of based on some stuff that I had done in the past, and he was asking me questions, and we met at a conference, and he's a lovely guy, by the way. At a conference, I spent like 6 or 7 hours with him trying to help him with this project. And so I'm like, I'd love to keep working on this, but I'm not just going to be like an acknowledgement, right? So I sent him an email, and I'm like, hey, I'd love, I think this is a really interesting project. I'd love to keep working on it. If the other co-author is okay with it, maybe we should chat, and I can officially be a collaborator. So like, you have to be delicate. Basically, I was saying, look, please make me a collaborator if you want my continued help on this. Because I was spending a lot of time on it, and so you have to be delicate like that. From Wayne Cottrell with the 5 pounds, are you familiar with Fraser Kane? And would love to see an interview with yourself on his channel. Love the channel. Keep up your great work. I do know Fraser Kane. I've listened to Science Friday for a long time. I haven't in a while, but I'm very familiar with it, and I would love to be on his channel. I would love to, do an interview with him. If you know Fraser Kane and would want to suggest an interview with me, please reach out to him. No, not to me. I won't have any say on it, but I would love to do it. I would absolutely do it in a heartbeat. From Shader Theory with the $2, unifying gravity within 50 years, continue 3D Navier-Stokes. Thank you. I can't make a prediction about any of that. How am I supposed to be able to predict when we'll have gravity unified with quantum mechanics in 50 years. I don't know. From Cade Green with the $5, thank you so much. What counts as an observer in quantum mechanics? Is it that to measure a particle's position you need to interact with it? Yes, it's exactly that. It is exactly that. And from Kirby Newkirk with the $2, Justin, you and Ian are awesome. Thanks for your time. Well, I appreciate that. Do you believe dark matter is actually a thing distinct from baryonic matter, or do you think we just not know enough about gravity yet? I think that it's actually a thing. Like, it would seem very, very surprising if it were the case that that like, oh, there's just no particles that we can't see directly. Like, that would be a little bit surprising to me. Could you please explain the covariant derivative? The covariant derivative is one way of measuring how a vector changes as you drag it along some path, in a way that preserves angles and lengths. That's well, okay. I should say that's what the covariant derivative on a Riemannian manifold, that's what the covariant derivative is using the Levi-Civita connection. But that's typically what most people mean in a geometric setting. A covariant derivative is really just a way of measuring how a thing changes as you drag it along some path, and so that you can compare the final and the initial. And there are canonical ways that you can figure out how to measure that change, but that's what a covariant derivative is. Since both a magnet and a lamp are explained by electromagnetism, what is the difference between the photons that carry the electromagnetic force in each case? Photons don't really carry the electromagnetic force, at least not really. So in most cases, the electromagnetic force is just carried by the electromagnetic field. Now you can describe the electromagnetic field as like a whole bunch of virtual photons, but those virtual photons are not real. They're not like actually there. It's just an electromagnetic field in a certain shape. I have some questions about motion. Is there any chance I could come up and talk about it? Yes, in about an hour. Do you think we will be able to detect gravitational wave memory with the BEW generation of detector? I don't know. It is something that I'm very interested in, though. Are you aware of the work that Thomas Townsend Brown did with scalar waves? I strongly urge you to read everything you can on it. So there are no scalar waves in electromagnetism. This is mathematically proven and experimentally demonstrated. From David's Orbit Science with the $2, do you believe our physical laws are invariant? Well, if they're not invariant, then there's probably a way of describing them that is invariant, i.e. these formulas change in this way in these situations, right? The actual physical distance an object travels along its unique path through the 4 dimensions such that, okay, I think that this was just an explanation for something else. If we join the Discord voice and won't be brought up until 90 minutes from now, yeah, so I'm gonna start taking guests in about an hour. At 10:30 Pacific time. Please explain the actual mechanisms behind magnetism to me like I'm stupid. Look, so the actual answer is that a magnet is just made of smaller magnets. That's the reality of it. And then there's the smallest magnet. These are the electrons. And those are just little tiny magnets. They're not made of smaller magnets, though. How can the universe be both infinite and have a beginning? I don't see the issue. It could be infinitely large and have a beginning in time. It could be infinite in the past and have a finite size. Blitz wants to find a physicist employed and actively working on research in an institution. No, I don't think you have to be in an institution. Because otherwise Einstein wouldn't have been a physicist when he was working at the patent office. But you do have to be actively working on research. I would say that that's probably true. You know, maybe Neil deGrasse Tyson gets a pass, but yeah, I mean, like, it has to be a substantial part of your occupation, right? Otherwise, you'd be conflating people who do this kind of professionally and treat it as their occupation, and those who do it kind of just as a side hobby. And so, you know, yeah, and like there are independent researchers who are just like independently wealthy, for example, and so, you know. From Gokul Vishetty with the 200 Indian rupees, does the conservation of information principle from physics apply for human brain or neural network? Can a human brain create new information, or does it only use the information it senses? So you're conflating information in kind of like the computer science sense with information in the physics sense. So information, conservation of information in the physics sense is just talking about how essentially it's something closer to like the conservation of probability. And so what we're talking about is we're talking about how the wave function should be reconstructible from any state. So the wave function at one time should be reconstructible from the wave function at any other time. But that has nothing to do with like creating new information as in like coming up with new ideas. It's completely unrelated to that. Can you explain paraparticles and why they're recently becoming more relevant again? So interestingly enough, and let me just show you my my Notepad app, because it's funny you mentioned that. So I have a Notepad app that just has a whole bunch of different like ideas for videos, and if I scroll way down, because this has been on my radar for a long time, I just haven't gotten a chance to make it. If you scroll way down, you see paraparticles. And so like it's on my radar to explain them. They're complicated, and I don't want to do them I don't want to do an injustice by explaining them poorly here, so I'm not going to, but eventually I will make that video. I'm an active professor, but I don't refer to myself as a scholar or a researcher because I don't do any active research. Yeah, I mean, like, that's fair. What are the most important programming skills needed for getting into research? It just really depends on what research you're getting into. Can you please debunk Utah politician? No, I'm not. I'm not going to harass a woman who is like very clearly mentally ill. Like I'm not going to do that. I'm sorry. What's the biggest difference between a mathematician and a physicist? Mathematicians prove things. Physicists sometimes prove things, but usually don't. What do you think the Big Bang says about time? I don't think it really says much about time. Does the quantum eraser experiment show time isn't real? It doesn't. The quantum eraser experiment just shows that there are correlations in quantum systems. Is studying mathematics at a PhD level make math make sense? It'll get harder, not easier. Is deep learning performing real renormalization group flow, or is the link to ADS-CFT space-time geometry just a surface level math analogy? I have no idea. I don't know anything about that analogy that's been used. Are you a mathematical realist? No. I'm a mathematical anti-realist. What in physics keeps you up at night? Not a lot. I sleep pretty well, to be honest. What are 5 major discoveries that have come from CERN? So I think I brought this up just a few minutes ago, but in the last 15 years, CERN has discovered the Higgs boson, a pentaquark, and a tetraquark. But I think they've also discovered like a whole bunch of particles. Also, the World Wide Web was invented at CERN. So, you know, make of that what you will. Can you explain Coriolis acceleration versus regular acceleration? Do you mean centripetal acceleration? Coriolis acceleration is not a phrase that's usually used. How do we know that quarks exist? Well, so imagine that you had imagine that you had 3 tennis balls that were attached really, really tightly by rubber bands, like into like a triangle shape or something. Now, most of the time, if you shoot stuff at that, it'll just bounce off those 3 tennis balls bound together as if it's just like one big block, one big triangular block. But sometimes, if you hit it hard enough, you'll knock one of the tennis balls out. And we did that with protons, and I think it was protons in particular. And you can see what happens when you knock a piece out, and you get these things called they're called jets, and they're evidence that quarks exist. Speaking of Levi-Civita connection, does teleparallel gravity interest you? Mildly. I have a colleague who works on it a lot, who spent a lot of time on teleparallel gravity. I'm not too bothered by it, but like, you know, I keep it in kind of the back of my head as like something that I should, you know, make sure I don't ignore. I want to research physics. Do I need to go into an institute? I always thought I would make a lot of money and do this as a hobby. Mostly I think I'm more interested in engineering. Yeah, so the thing is if you want to, and this is probably true of every physicist in the last 50 years, it's probably the case that if you want to do physics research, you probably need a physics degree, several physics degrees, ideally probably one of them is a PhD. Because there's just a lot of background physics that you need to know in order to be able to push the boundary forward. And it's very hard to get that information, very hard to learn that material just kind of as a hobby, because it's a lot. Like, you know, you're a full-time student for, you know, at least 6 years when you go from, you know, high school to a master's degree in physics, which is where you, by that point, you've finished all of your classes. So there's a lot. there's a lot to learn, especially if you're doing it as a hobby. You don't have to be at an institute to do research in physics, but it definitely helps, especially if you have never had an institution affiliation before. I'm currently not affiliated with an institute, but I can still publish because in some sense, I've made a name. So like I have a publication record. I'm not just like some crank off the street. Like people, the journals that I submit to have seen my name before. There's nothing super sneaky there, but it will be harder if you don't have any affiliation at all to submit papers anywhere. From HMBS with the €1, thank you so much for the donation. And from the Basist with the $5, which magic system in fiction would you most like to be an in-universe researcher for? I don't know. I haven't read a lot of fantasy fiction. Like I used to a lot, I just haven't in a long time. The Name of the Wind was really interesting. I don't remember exactly how it worked, but it was a really interesting idea if I remember correctly. Sorry, I have to jump down to the bottom because you guys are asking so many good questions. I want to be a physicist in India. Okay, be a physicist in India. What is, in your opinion, an underrated field of physics you discovered during your studies? The fields that I like are the most overrated ones. I like cosmology. I like black hole physics, but those are super overrated. Probably underrated would be things like plasma physics, AMO, complexity physics. So what degree can you genuinely understand physics without being good at math, like actually solving? The surface level. You will only ever really get to the surface level unless you can actually follow the math. Unfortunately, that's just reality. Like the language of physics is mathematics. Not to pry too much, but if you aren't working at an institute, how do you pay bills? This is why I'm encouraging super chats, because you guys are helping fund my research, helping fund my my research program. I also have some Patreons I have one Patreon specifically who funds my research specifically rather than funding the social media stuff. And then I create science content. Keep in mind, if you work at a university, often the way that you pay for your research is by you have to teach classes, right? Either that or you get a grant from the government, in which case that kind of covers your classes. So, you know, I create explainers on YouTube and TikTok. It's my way of teaching. Blitz, have you thought about getting back into an institution, or are you going to continue with being an independent researcher? At least for the time being, I'm going to continue being an independent researcher. I might, at some point, look to get an affiliation at my local university just so I can get a .edu email address. But I don't know anybody particularly well there, so I might have to go ingratiate myself with some people there so that they could justify giving me a .edu email address. Yay, astrophysics is my favorite. No, I'm not an astrophysicist. Astrophysics is not black hole physics. Astrophysics is not early universe cosmology. Those are not astrophysics. It's black hole physics and it's cosmology. Astrophysics is a different thing. What's AMO? Atomic, molecular, and optical. You get to play with lasers. From Tinky Pixie with the $20 Australian. Thank you so much. I appreciate that. Do you know Albert Sneppen research? Never heard of him. Can sound escape a black hole? No. What is the most complete and well-understood field of physics? Probably quantum electrodynamics. Maybe slightly off topic, but can you explain van der Waals forces? So van der Waals forces are just kind of residual forces left over from it, like residual forces left over for otherwise neutral atoms. So if you put two atoms next to each other, you can think of them classically, right? You have your electrons going around the atoms. When the electrons are close to each other, they will want to repel, and when they're far away from each other, they will want to attract. And so they kind of want to be kind of out of phase, and so you'll have an electron that's closer to the proton, and so you get a small residual attraction. Is the right way to think about it. At least that's one way. So like the explanation was not quite right. Suffice it to say, as a result of the geometry and the neutrality of the atoms and the way that the electrons are distributed around the atoms, you can get a slight attraction between things that are otherwise neutral. It goes as like 1/r⁶ or something. Maybe I should add that to, I'm gonna make a video about that. Van der Waals forces. That's a good topic. From HMBS with the €250, Nima says the idea of discrete spacetime is naive. Agree? I don't know. Like maybe it's naive in the sense that like it's like something else is there's something more fundamental than space-time, but it might not just be individual points that are discrete. Maybe. From Victor Weirich with the 2 Brazilian reals, or maybe it's Weirich. What does black hole entropy count? We don't know. String theorists think it counts like string degrees of freedom, but this is one of the issues, one of the big issues, right? Renormalization in QED might be wrong. Yeah, but it makes the best predictions, so it's wrong, but in the right way. Any remarks on Grush's and other people's public testimony and its implication to the institution of academia and specifically physics? All a hoax that will go away once the mad tyrant is gone? I have no idea what you're referring to. Debate angels again. I'm good on that for a while. Until he figures out what relative motion is, we're probably not going to do a debate. I'm looking for reasons to reject the A theory of time. What's your best one? Relativity of simultaneity. That coupled with the Andromeda paradox, which comes from relativity of simultaneity, is really quite a good reason. So look into that. From JP Morax with the 5 Brazilian reals. Math perspective, does QM measurement alter the state purely via physical interaction with the detector, or is quantum probability non-epistemic? This is an interpretation question. And I think that you mean is quantum probability purely epistemic, right? So what is known is that interaction does cause a change in behavior. The question is does that change in behavior include a collapse or not? And that we really don't know. The math perspective, it just depends on which interpretation you use. From the mathematics point of view, if you just take the Schrodinger equation, then there is no collapse. There's no collapse built into the Schrodinger equation. You need to kind of add that in by hand. And from Jonathan Martin with the $20, thank you so much, bud. My contribution to your continuing independent research and work as a public science educator. Flirfs run in fear. Indeed they do. In fact, they run so fast that they don't show up anymore. It's much appreciated, though. How sure are we about there being infinite number of universes or more than 4 dimensions? We're not sure about that at all. Neil Turok, Higgs chair, recently seems to have made progress with quadratic gravity on your radar. Nope, not on my radar. Neil Turok is a very good scientist, though, so I wouldn't be surprised if he's doing something interesting. What's the biggest question in physics we are the closest to answering, in your opinion? It's hard to know when you're close to answering a question if you don't know what the answer is, right? It's easy in hindsight. Like in hindsight, relativity was inevitable given Maxwell's equations, right? But at the time, it seemed like there's nothing inevitable about it. Is the inflationary universe simply too large to infer topological structure from our horizon? Perhaps. It might be the case that you can't infer the topology of the universe at all, because there's just like other stuff going on that we can't see, but it's hard to say. To what extent does the quality of the university you study at affect your career as a researcher? So unfortunately, the reality is that there is an elitism problem. Namely, the people that get hired are the people who have prestige. Now, there is a correlation. There's a strong correlation between the people who are very accomplished scientists and the people who happen to be at the very prestigious universities. But there are other ways to get to a prestigious university that doesn't correlate, or that don't other ways that don't correlate with your capability as a researcher. And yet, because you know the right people, because you have the right pedigree, that can positively affect your career. So there is an extent to which, if your goal is to work in academia, you should shoot to go to the best universities you possibly can. And don't settle until you're 40, and then you can have tenure, and then you can settle and stop stressing. If water cannot be compressed, how is the Big Bang Theory possible? Water can be compressed, but also water didn't exist 13.8 billion years ago. What do you think about the Kurzgesagt YouTube channel? They do really, really good animations. I haven't seen their stuff in a long time. I think that they do a decent job. In one of your videos, you said that you lived in Brno. So is your nationality Czech or any other? I'm not Czech. I lived there for a postdoc that I did for 3 years. From Veronica Cromit with the $10. Thank you so much, Veronica. Best way to know what we should... Let me try reading again. Best way to know what we should keep up with as a layman. Want to stay up to date but value accuracy and my time. Example, what's up with twister theory, worth it or not? Okay, so the best way to do this is probably to, honestly, so there's a few good websites. Like if you go to Quantum Magazine, phys.org. If you go to phys.org is generally really reliable, really good, because they're run by APS, I think. The American Physical Society. I think that they're run by APS. So they're really good. They have, they will write articles. But honestly, if you go watch PBS Space or PBS Space Time, if you go watch Dr. Becky Smethurst on YouTube, they will report on stuff in a very reliable way. I've never found a video that they've made that's been unreliable. And they will, if something's interesting, they'll keep you up to date with it. Now, as far as twister theory is concerned, twister theory is not new. It essentially Roger Penrose invented it back in like the 60s. And he thinks that it's like the best way to do physics. And it's had a lot of wide applications, but it's not like something that you should worry about. It's like a mathematical tool. Is that phys.org? Yeah. phys.org. When are you going to get back to playing Kerbal Space Program? When I have Saturdays free. My Saturdays have been jam-packed lately. So this past Saturday was my wife's birthday, so I wasn't available then. The Saturday before that, I was out of town. The Saturday before that, I was out of town. The Saturday before that, I was socializing with some friends. We were getting lunch somewhere. The Saturday before that, I was, that would have been, the Saturday before that was my birthday. The Saturday before that, I was out of town. So I've just been out of town a lot. And so once I get some free Saturdays, I will. From Chase Teaches Physics with the $2, study strings, abandon all else. No, don't do it. Don't listen to him. He's a string theorist. From Garain with the $5, what are the top 5 biggest unsolved problems in physics besides quantum gravity? I mean, it just depends on your field, right? So there's a lot of unsolved problems in each different field. The thing that I am probably most interested in is dark matter, dark energy, Big Bang. Quantum gravity is the big one. Neutrino masses. Trying to think of like what would be a good fourth. Maybe topology of the universe. Those are really interesting questions for me. But those are, they're personal, right? Like, I didn't mention anything about QFT. Quantum not here. Quantum's like neutrinos. Proton mass and spin. Proton mass is just a QCD problem. It's uninteresting to me. Are you currently working on any papers /research? If so, what? Yes, I am. 2 of the physics projects that I'm working on, I'm keeping kind of close to my chest because, they're in their infancy and I don't want the ideas to get out to the public until they're published. But I'll tell you one thing. One of the papers that I'm working on, it's very, very new, by the way, but one of the papers I'm working on is I'm working on with somebody that I met on TikTok. I don't want to spoil it, so. Does light ever reach the Planck luminosity limit? Luminosity limit? I suppose probably not. You mean like emitting 1 Planck energy per second of light? Like probably not. 1 Planck energy worth. Actually, maybe it could be Planck. So we really want the Planck power. So the Planck power is 3.6 times 10 to the 52 watts. So I actually guess that, yeah, I don't think that there's anything that actually does emit at the Planck power. So I guess the answer is no. Any idea how reliable the latest GPT model is with things like linear algebra? It's actually pretty good as long as you're using a paid version. I haven't used a free version in a while. But yeah, it's actually pretty good. They haven't solved everything yet. When do we stop calling them scientists? What? What? Do you think humanity will become a type 1 civilization within the next 100 years? Maybe. The Higgs force is at a false lowest resting point, and if it reaches a lower point, it would remake the universe in an expansion from that point. Could the universe be moving through cycles of this? Probably not, unless there is some sort of ratchet that the Higgs field falls down. But as far as I know, the Higgs mechanism doesn't have like an infinite series of minima. What should I have to do in college as I want to be a physicist in the future? As at now, I am in computer science field in an average third-tier college. Please guide me. You should switch your degree to physics. That's what you should do if you want to be a physicist. Like, that's the most likely way to get you to where you want to be. Which European country is best to pursue physics PhD? If you count England, probably England. Would probably go to Cambridge or Oxford. Maybe Cambridge is better in physics and Oxford is better in mathematics. Hard to say. Any thoughts on anti-gravity research? The only anti-gravity research that I think was at all legitimate was that done by Ning Li back in the 90s, and she made a prediction with her model, and the prediction was false. They did an experiment and it didn't come up. Her prediction didn't come true. So the proposed anti-gravity mechanism just didn't work. He's only reading YouTube chat? No, I'm not. I'm reading both. Are you interested in gravitational waves at all? Yeah, I am. I'm not really interested in like the nitty-gritty aspects of gravitational waves. Kind of interested more in like the kind of like the fundamental features of gravitational waves rather than like predicting the exact shape of gravitational waves and so on. But yeah, I am. Are fields 2D or 3D, or is it another dimension? So quantum fields they live in the four-dimensional spacetime. They take as inputs four-dimensional spacetime, and they take as outputs infinite dimension, or they give as output infinite dimensional operators. Why doesn't string theory fit well with the standard model? The thing is, it probably does. You just need a lot more on top of it. Explain why the theory that when the first nuclear bomb was dropped, it would ignite the atmosphere with neutrons continuously hitting other neutrons and expanding its bubble of energy until it ignites. Well, the thing is they were wrong. I don't know what's to explain. From Gray with the $1, thank you so much for the $1. It's appreciated. I need to drink some water because I'm going to get dehydrated otherwise. Oh, from Casey with the $6.66 on Venmo, writing, oh wow, I think Casey is like really cool and so smart. It does work, it turns out. But thank you so much, Casey, I appreciate that. Okay, keep reading. What is causal set theory? It is a framework for doing quantum gravity. It is like an idea, like a way, kind of like it's a way or an attempt to do quantum gravity in a certain kind of novel way. And from Chase Teaches Physics with the $5, is it more that we don't know which of the possible... Oh, it is more that we don't know which of the possible 10 to the 500 string vacua can make the standard model without it having exotic U1 fields added. Yeah, that's what I was saying. Like, it could very well match the standard model. We just don't know which one does. What would you recommend for an undergraduate CS student to switch their degrees to physics? What would I recommend for them? I would go talk to the physics advisor and be like, hey, I want to switch my degree. Can you give me any advice? Do you believe we are in an ever-expanding universe, or is it going to implode one day? I'm pretty agnostic about the issue, generally. How big could we make a cannon before we break physics? Like a cannon? I guess you could make it like as big as a planet, but it'd have to be gravitationally stable. If I take all upper-level physics courses, can I still apply for a PhD with a minor in physics? Probably, yeah. What are your thoughts on a cyclic quantum universe? I don't know what you mean by a cyclic quantum universe. The Webb telescope's new faraway discoveries. Are those supposed to be connected thoughts? I think that a cyclic universe shouldn't be ruled out yet. But as far as I know, we haven't seen any evidence from the Webb telescope. If I take all upper, oh, I already answered that. Can you explain what physics breaks down into singularity means? It means that like we can't make sense of, like the predictions don't make any sense. Physics is about making predictions about the way the world is. And if you're if your claim is that there is a singularity, then somehow you're predicting something that's infinity, that like that some measurement that you can make that would give you infinity as an answer. And infinity is not a number, it's not a quantity that you can measure. So the physics stops making sense. How do you go about writing a paper from idea to publication? Well, you have an idea, and then you have to do a lot of work to make sure that the idea works, right? You have to do calculations, or you have to do some reading, or you have to do some proofs, or whatever it might be. You know, it depends on what kind of idea it is. You have to maybe test against some data. You have to maybe explain an experiment or something like this, or design an experiment and then run the experiment and collect data. Whatever it might be, you have to figure out whether the idea is good. And then it's a matter of sitting down and writing it up. And that's kind of a long process. You have to make sure that you do the correct literature review, that you read the correct sources, that you're not stepping on anybody's toes, and then you submit it to a journal. Are dark stars a thing? Not that we know of, but maybe. Why does string theory require so many spatial dimensions? So the explanation that I was given, that I saw when I was a graduate student, is that there is a quantity called the conformal anomaly. The conformal anomaly is basically you can think of it as a property of like any quantum system, or of any quantum theory, whether it's string theory or quantum field theory or whatever. And the conformal anomaly has to be 0 in order for a string theory to make sense. Like this is something that you can prove. Like it just doesn't make sense. Nothing works if the conformal anomaly isn't 0. And it turns out the conformal anomaly is related to the number of dimensions that you have. In particular, it's something like d minus 10. The number of dimensions minus 10 in superstring theory. And so the number of dimensions has to be 10, otherwise you just get inconsistencies. The number of dimensions has to be 10, but this number of spatial dimensions has to be 9. And Chase is of course going to have opinions about that, because Chase is the local string theorist. About renormalization, isn't it just a trick that involves a fine-tuning rather than an amazing tool? It's not really. It's only fine-tuning if you think that the measured thing is the fundamental thing. I'll put it that way. From Git Stanfield with $5, does the current consensus in physics still agree that the heat death model is eventual, or is it more contentious at the moment? It's not clear. I think that people are probably a little bit less certain now. If gravity is quantized, why haven't we seen gravitons yet? Even if gravity was quantized, which, you know, it probably is, the ability to see gravitons would require extremely sensitive machinery or extremely sensitive detectors that we don't have. I found great interest in fundamental physics and thinking of studying it in college, but I'm worried to dedicate my life to something I know little about. What do such careers actually look like? Most people who get a degree in physics, an undergraduate degree in physics, don't end up working in physics as their career. So you could get an undergraduate degree in physics and then just go do something else. That's typical, actually. Oh, I need to jump down to the bottom because I'm way behind, sorry. Is Yellowstone going to erupt in our lifetime? I don't know, go ask a geologist. Do you believe information pressure is the missing force to file systems? No. Have you ever been to see a Large Hadron Collider? Well, there's only one Large Hadron Collider. It's in Switzerland. And no, I haven't seen it. From Chase Teaches Physics, here's the explanation. Thank you so much, Chase. Ghost particles create negative probability predictions. Eliminating ghosts requires 26D. SUSY allows 10D or 11D by changing ghost particle structure. There you go. I'm not wrong about the conformal anomaly thing, though, right? RHIC is not a Large Hadron Collider, though. RHIC it's a relativistic heavy ion collider, but it's not a Large Hadron Collider. The Large Hadron Collider is in Switzerland, and that's the only one. If information cannot be distributed faster than the speed of light, what about tangled particles? They don't convey information. They don't convey information. I need to not slur my words. That sounds like I'm drunk. I'm not drunk. I just sometimes talk too rapidly and my words string together. How cool is it that you can share your knowledge on this platform with your reach? You're rocking the world. I appreciate that. What does it mean for electrons to have spin? Well, they're like tiny balls that are spinning, except they're not tiny balls and they're not spinning. I mean, it's a meme answer, but essentially they have angular momentum. Angular momentum is a quantity that's conserved in our universe. Namely, you can't just throw away angular momentum without it going somewhere else. But if you try to account for the angular momentum of an atom, what you find is that unless electrons have spin, for example, unless they have angular momentum themselves just intrinsically, you'll get the wrong answer. Like, the angular momentum won't be conserved, but we know it's conserved. And then we can actually measure the angular momentum of electrons by passing them through, say, we can measure the magnetic moment by passing them through magnetic fields, for example, and measure these things. From Jason Samuel Harden with the $2, has string theory or dark matter been proven? String theory has not been proven. Dark matter has been proven is a strong word, but there's a lot of evidence for dark matter. Let's put it that way. If the problem with quantum gravity is that infinities that can be normalized, if the problem with quantum gravity is that infinities that can be normalized arise when you combine GR and quantum mechanics, why not treat it mathematically and make a method to extract information, for example? I don't know what the question is asking. The point is the mathematical tools that we usually have to quantize gravity don't work. Holographic dark energy gives an asymptotically static universe. Does Desi's wow fit help or not? No, it doesn't give an asymptotically static universe. That was one of the points of the paper that I wrote with the two colleagues. Oh, I need to hide that. Show evidence for any of your claims? I mean, you can check anything that I'm saying. You can check that it's correct. From Chase teaches physics. From Chase teaches physics with the $2. You are right. Conformal anomaly. Introduce ghosts. Okay, there we go. I'm glad that we agree. I'm not a QFT guy. I'm not even a particle physicist or a field or like that. All that stuff is classical string theory is where it's at. Have you always been a competent public speaker, or is it a skill you developed? I guess I just got practice speaking in front of classrooms, and that's basically public speaking. From Victor Virich with the 2 Brazilian reals, thoughts on Brazilian universities and academia? I don't know a lot about them, so I don't have any thoughts on them. Math major thinking about doubling in physics. Is it worth taking a physics class on waves before quantum mechanics? Yes. Oh, I feel like I'm gonna have to sneeze soon. Hey doctor, can you explain how a photon has momentum but not mass? Because because momentum is not intrinsically linked to mass. For slow objects, the momentum is for objects with mass, momentum is intrinsically linked to it, but for objects without mass, it's just not. And momentum is again a quantity that's conserved. And if you try to account for the momentum of a system, but you forget to account for the momentum of electromagnetic waves, for example, then you will get the wrong answer. And you can measure the momentum that a photon has. This is how we make light sails. You can also measure the mass of a photon and you get 0. From Jason Samuel Harden again with the $5. Is the God particle able to be created with modern science and technology? Yeah, that's what we did in 2012 when it was discovered by at the Large Hadron Collider. We made one for the first time. And it's not the God particle, it's called the Higgs boson. Is water scientifically wet? Yes. I will take no questions. What's plutonium-238? Plutonium-238 is an isotope of plutonium. Plutonium is a radioactive element, and it has 94 protons, and plutonium-238 has 144 neutrons. And because of the number of neutrons that it has a half-life of around 87 days. From Mindos with the €2, was the early universe like the core of a star? In a sense, but there weren't atoms yet to be fusing. What experimental result would convince you that string theory is the wrong approach? If you were able to probe the Planck scale and string theory made false predictions about what the expected outcome was for the string scale, or for the, the string scale, then, or the Planck scale rather, then that would be good falsification. Oh. Is the photon the only particle in existence that has no mass? Nope, gluons also have no mass. Is created the right word there? I mean, yeah, like Higgs bosons didn't exist in, Higgs bosons don't just exist like every which way, right? And then we created one. We made one. We did a thing, and on purpose, a Higgs boson began to exist. Now the Higgs field is everywhere, but Higgs bosons, they are very temporary and they don't really exist naturally. At least not anymore. If the law of conservation of mass is real, then where does my box go? What's your favorite constant? 1. I'm quite fond of 1. What's element 115 used for? Absolutely nothing. Oh, have you always been atheist? As far as I can remember, yeah. So all matter in the universe is fundamentally made of photons? No. No. In fact, no matter in the universe is made of photons. You have a good memory regurgitating all this you've been told so quickly. You say regurgitating? I mean, like, it's regurgitating all this you've been told so quickly. It's called learning. Like, when you learn something, you don't, like, you understand it so that you don't have to memorize things, right? It's just called learning. I'm open to pretty much anything, but string theory is a pure scam. $30 billion scam. Okay, I don't think that $30 billion has been invested in string theory. How much money total has been spent? Let's find out. This is actually an interesting question, because I suspect it's much, much lower. Okay, so go to physics forums. So since 1976, it looks like maybe $200 million from the NSF. Maybe $500 million across the world or something like that over 50 years. So let's work out the details there. So over 50 years, $500 million is what? $10 million a year, and across, say, 1,000 researchers, maybe there's 1,000. Let's say that there's 1,000 researchers, that's 10 grand a year. Like, across the whole world, $500 million in 50 years is not a lot of money. From Jason Samuel Harden, again with the $5. If the galaxy is 13.8 billion years old, how can scientists prove that a black dwarf and a blue dwarf stars will exist one day? Well, the galaxy isn't 13.8 billion years old. You're thinking of like the universe. But the point is we have a pretty good understanding of how stars change over time. And so the idea that a white dwarf eventually becomes a black dwarf is really easy to establish, because a black dwarf is just a cold white dwarf, right? That's all it is. And so white dwarfs will eventually cool down and become black dwarfs. And I've never heard of blue dwarf stars, but I imagine it's similar. What was your dream job when you decided to be a physicist? Tenure track faculty at a university. However, I've recently realized that that might not be exactly what I wanted. Because it turns, well, so maybe that would have been the dream job 10 years ago or 15 years ago. Like if I could have a position 15 years ago at a university, but like these days, I'm such a doomer. Like with AI and with the current administration, it's so bad like in academia these days. From Chase teaches physics with the $2. Got us. We just don't care about truth. We don't care about truth. Just $50,000 a year salaries. True. Exactly. String theorists don't make a lot of money, right? They spent more money marketing string theory than researching. That's not true at all. Like, you're just making stuff up. I will not stand for this string theory slander, by the way. Do you believe in ghosts? I don't. Why would the intuitive thought fail that universal expansion leads directly to the rotation curve seen in galaxies? I don't see how there's any connection between those two. Have you ever been to Cedar Point? Yeah, I was at Cedar Point like last week, I think. I was at Cedar Point on July 18th. So if you saw me there, then you should have said something. Do you think it's too late to become a PhD physicist? 35 years old. No, it's not too late. But, you know, the thing is when you're that old, it's hard to want to do homework, right? Did you ever think about going into medical physics? I didn't. No. Just not interesting to me. From Anna Unplugged with the $20. Thank you so much. In what world? In what world? I don't know. This has got to be in reference to something, right? But I don't know what it's in reference to. Hold on. Yeah, I don't know what it's in reference to. Sorry. What is dark matter? We don't know exactly yet, but we've ruled out a lot of things that it isn't. Did the graphite tips on the control rods cause problems at Chernobyl, and if so, why? I don't know. I don't know enough about it to make the claim. Do you believe that the I think he's only reading Twitch chat? Twitch hardly has any chat. Do you believe that the ekpyrotic universe is true? I don't believe it's true. I think it's a possibility. Any advice for an incoming college student majoring in physics? Go to office hours. Just do it. Go to office hours. 34-year-old PhD student here. Homework is definitely exhausting. Yeah, right? Like, I mean, I was able to just sit and do homework for like hours when I was in undergrad. I'm just not sure I'm ready for it. I'm just not sure I could do it anymore. You're way behind on TikTok? Well, look, so I'm behind on all of the platforms. There are 4 platforms all sending messages, so I can only answer so many. From Anna Unplugged with the $50. Thank you so much, Anna. No other question, thank you. What? Why? I'm so confused. Anna, thank you, but I'm so confused. And from Jason Samuel Harden with the $20. With your knowledge, how long do you think it will take humanity to colonize another planet? And I've been trying to solve string theory since I was 18, and I don't have any experience in physics. I do study a lot. It's fun to solve. Well, good luck solving string theory. There's a lot of people trying to do the same. I hope that you are paying attention to the research that's being done there. As far as your first question, how long do I think it will take humanity to colonize another planet? I could see us colonizing a planet in our solar system in 50 years. Within the next 50 years, or at least like putting people there. Not like a full-fledged colony, I don't know. But colonize it, like putting some humans down in like a permanent settlement in 50 years seems plausible. Yeah, it's a little empty over here. Yeah, so not a lot of people watch from Twitch, but you know, we love the people who are watching from Twitch. You guys are the best. Love you guys. Love all these subs. That did not come out right. Why hasn't anyone made a model of the universe? What's the challenge? We have. That's what cosmologists do. He isn't reading YouTube comments. I'm reading all of the comments. I just can't get through. I can't hit all of them. How probable do you think the existence of other multicellular life in the universe is? I think it's really probable. Seems super, super common. It seems like it should be super common. Do you make teaching videos? In a sense, yeah. So I actually do have, and this reminds me, I need to update my website to include this. So when I was a grad student, I posted lectures for like a full year of intro physics, like calculus-based physics for engineering students, but there's a full year that I posted of lectures from the COVID days. So you can go find those online. I should link them on my Discord or on my website at some point, because those are like, it's actually just like a full university year's worth of courses. There's like, you know, 100 plus lectures or so. Well, across the 3 courses, it's probably like depending on if you like the 50-minute long lectures or the hour-and-a-half long lectures. If there's like 60-ish 50-minute long lectures. It's there, it's on YouTube. I just need to link it to my website. I also need to get permission because I was teaching at a university and I was using like a textbook that, so like there might be some legal issues there if I like claim it's mine and all of that stuff. So what other platforms am I streaming on? There's two YouTube channels. One's vertical, one's horizontal, and then there's Twitch. From William Fitzgibbon with the $2, favorite undergrad math class. You might be surprised to know that it was probably number theory. And the reason it was my favorite was because I took it with an incredible professor. He was so fascinating. He was like such a good educator, and he made it so interesting. Like his lectures were fascinating, and the homework assignments were thought-provoking. Like it was just really, really good. All right, I have to jump down to the bottom. What do you think of China's, I don't know what to say. What do you think of China's new Inventors PhD Awards? I think it's interesting. If gravity is the curvature of space-time, does the idea of gravity being different even make sense? Yeah, sure. It could be curving in different ways. Can condensed matter physicists become material scientists? I guess. There's probably a lot of overlap there. Have you seen the guy here on TikTok that says calculus and math are wrong and he's smarter than... I haven't, so tag me in a video if it goes viral or something. Would you say if I watched all your YouTube videos courses, I would have a good fundamental in physics? Well, you'd have to watch them and then do exercises to do the physics. Physics is not a passive, it's not a passive thing. Did you do a video on January Janice? No, I'm not, and I'm not going to, because it's pretty clear to me that she's mentally ill and I don't want to punch down. In your opinion, is there any merit to the one electron universe proposed by John Wheeler? No. And he probably wouldn't think so either if he lived today, because that idea was kind of proposed before they had a really good basis of what quantum fields were. From Beebs U2B with the $10, I appreciate that a lot. Thank you so much. As a fellow scientist, I admire your ability to both lead people through evidence and offer immense patience to those engaging in good faith. Do you have any opinions on grant cap changes at the NIH? I haven't heard about the grant cap changes at the NIH, but these sound bad if they're decreasing the caps. I don't love that a lot. But I haven't heard about it, so I hope things are going well with you, Beebs. Thank you so much for the $10 super chat. From Victor Wyrich with the 2 Brazilian reals, do you ever collab with mathematicians in research? A lot, actually. Most of my collaborations are, well, about probably 60% of my collaborations are with mathematicians. Like I go to go to mathematics conferences. I also go to physics conferences, but like, yeah, I kind of toe the line. Why gravity is not fourth force since it's not a force, the result. Why gravity is fourth force since it's not a force, but the result of curvature. It is a force. All forces are the result of curvature. If energy isn't tangible or we can't see it as it isn't physical, how do we know it's real in there? It's not real. It's not there. Energy isn't a thing. It's not a real thing. It's just a number. Just started Carol's Quanta and Fields book. Do I need to be well-versed in calculus to understand? I suspect, to some extent, probably. What's a clock field? It's a quantum field that looks like a clock. I know it's not satisfying, but... Can you explain the connection between gauge theory and principal fiber bundles? That is an entire course, but essentially gauge theories are physical theories that live on principal fiber bundles. That's it. I mean, there's way more, obviously, but like a gauge theory is like a kind of physical theory that where like the fundamental objects are connections, and those connections are in principal fiber bundles. From FF9S6B2 with the $2, is the black sun made of Flex Seal? Yes, it is, actually. Indeed it is. Quantum entangled communication to skip time lag. Already put my question down. You can't communicate with quantum entanglement, unfortunately. In your time debating flat earthers, influencers, flat earth YouTubers, influencers, have you ever managed to change their views? Not the influencers, but I've changed some normies. From Benjamin Sadik with the 15 shekels, do you know anything about continuum mechanics? Most physicists don't, since it's the basis for GR and QM. Anyone looking for unification should. All physicists know about continuum mechanics. Continuum mechanics is just classical field theory. From Anna Unplugged with the $10. Sorry, first time here. Well, look, if this is your first time here, I appreciate you a lot. Thanks for being here, and thank you for all of the super chats. Did you have any projects at CERN? No, I never worked at CERN. I would have loved to, just to visit, so I could have an excuse to go to Switzerland, but I didn't have the opportunity, unfortunately. After supernova, why neutrino come first and then photons since they have a small mass? Right, because neutrinos can basically pass through the supernova, essentially unimpeded. The photons coming from the core have to pass through all of this dense material, and that delays them a bit. Basically, yes, it is true that neutrinos are going to pass through the supernova shell, kind of, more slowly than the speed of light in a vacuum, but the light coming from the core is not traveling through a vacuum, it's traveling through a very dense medium, and so it gets slowed down. Why do forces follow the inverse square law? Is it modeling like projecting lines on a surface? It's something like that, but it goes a little bit deeper. But yeah, essentially it's because the way that forces seem to be described, these are things called Yang-Mills theories. The electromagnetic force is the prime example, or the simplest example rather. The mathematics of the theory force it to have a divergence theorem, or a kind of a divergence law, or Gauss's theorem you might want to call it. And that, in 3 dimensions, that automatically gets you an inverse square law. What do you think about quantum gravity? Interesting and worth studying. Do white holes explain dark matter? No, they don't. How much differential geometry do you think should be in the undergrad physics curriculum? Probably not very much. The NIH is proposing to cap the number of grants a PI can hold simultaneously at 3. Given that grant budgets aren't enough to cover our expenses in biomedical research, I think that's a real problem. That sounds like a problem. But is it normal to have more than 3? I think particle physics is false and everything exists photonically. Thoughts? Sounds delusional. Where did I go to university? I got my PhD from UC Davis. Is it possible that the theory of everything could contain an infinite amount of variables? Well, then it wouldn't really be a theory, would it? Right. Why are neutron stars so dramatic? They just are. They just be that way. From FF9 with the $5 again, if you had unlimited funding to answer one question, what would it be? I don't think funding is an issue right now. I mean, like, funding is always an issue, but like, it's not like we can't afford physicists these days. Like, there are still lots of scientists working in the field. It's just an issue of either time or we need the right ideas. Now, maybe if you had unlimited funding, you could build like a particle accelerator the size of the solar system. But even then, like, yeah, maybe that's the thing to do. Use the unlimited funding to build a particle accelerator the size of the solar system, and then figure out what's going on at the quantum gravity limit. All right, it is 10:30, so that means I'm going to switch over to taking on guests to ask questions via, the guest box. I will be taking on guests via Discord as well if you don't have TikTok. That also means I will be turning the live stream over to subscribers only. Not everybody can watch, but I'm going to be limiting it now so that only subscribers can send questions, or members, or whatever the official label is on each platform. So I'm going to restart the TikTok live, so feel free to hop on over in just a moment. I just got to give me 1 second to do that. Everybody can watch though, and anybody in principle can join up to ask questions. So 1 moment, everybody. All right, got to restart the TikTok live. I'll be right back. Do 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 do. Yeah, if you still want to send chats, because the reason I do this is so that people who are supporting me, like if they are members on YouTube or superfans on TikTok or subscribers on Twitch, their text questions, if they don't want to come up and ask them, are basically guaranteed to get answered, even if they're not sending a super chat. So consider becoming a member. It's like $5 a month, and you can get your questions answered on Tuesdays and most Wednesdays, but there's one Wednesday every 3 weeks that you can't get it answered because I won't do it. Jord, welcome to level 1. Thank you for becoming a subscriber, or a member rather. Much appreciated, Jord. All right, let's bring up Daitoni, who has a question. Daitoni, how's it going?
Not too bad. How about yourself?
I'm doing all right. Daitoni, what you got for me? What questions you have?
The question that I have is about time B theory, about how the future, past, and present would all exist at the same time.
Mm-hmm. My
question for you is, do you believe in that theory, or do you have any kind of like evidence that would strongly support that?
So
I only ask this because I have personal experience
so yes.
that shows that.
So yes, I think that the B theory of time is probably most likely to be correct, and this is based on Einstein's relativity. Relativity basically indicates that there's no preferred reference frame, and so there's no preferred slice of now. And in fact, every slice, if there's no preferred slice of now, then that would indicate at least that every slice of now is equally real. Zaitoni, do you happen to be driving?
No.
Okay, because there's a lot of background noise. But yeah, so I take B theory to be likely correct, and I take it to be that way because of Einstein's relativity.
Okay, and my question, I guess to follow up on that, if time B is true, does that mean that the events that would take place for you and I tomorrow exist somewhere?
Yeah, they exist. They exist tomorrow.
Okay, but what I'm saying is there any way for us to collect information from that future that exists, but just not currently for us at this moment? I guess what I'm trying to ask
is... unless you can, until you're then.
And that's typically what I would think too, but I have some personal experience that obviously I can't test or like prove to you, but I have some experiences where it shows me that what is going to take place tomorrow, conversations I'm going to have tomorrow, a building I'm going to see tomorrow, I will get information about it before it actually happens. And then when it does happen, the information that I received was exactly correct.
Okay, but that seems like it's independent of this idea of whether A theory or B theory is true. Any other questions you got for me?
No, that was it.
Okay. Well, thanks for being here. I do appreciate it. All right, let's answer some questions that are in chat. If there are any questions in chat, there might not be, because we did restrict it a little bit. But this is hopefully encouraging people to help support me, help support the channel. Just double checking for questions that I missed. I curled my front hair with hands because I pray to someone. It's not some new gen window. Okay. Have you seen the new study that explores the infinite potential that could be present if a photon could be theoretically split? I haven't. That also sounds made up. Like, I'm sure that somebody wrote something, but that's not the kind of thing that like a physicist would write. And like, you can split photons. You can split photons using something called a nonlinear crystal. There's something called spontaneous parametric down conversion, which is a way of basically taking in one photon and turning it into two lower energy photons, and you don't get more energy out, right? And from Godokuri with the question, for the people who say we are in a black hole, how does a black hole exist inside a black hole? That is a great question. It just would. You could, like, nobody really has a good model for this, so they just say, oh, well, inside a big enough black hole would look a lot like a universe, and then you can just have regular universe stuff in the universe. Like, I don't buy it either. That is making the rounds as Pop News article. I saw it last night. Let me take a look. Split photon infinite potential. I'm curious. Physicists find a way to split particles of light in half to make infinite photons. Yeah, that sounds really bad. Okay, there's an article on phys.org, so we can read this. This is from like a month and a half ago. Cutting a photon in two creates an infinite swarm of particles. Okay. A new theoretical study published in Physical Review Letters, Johannes Skar and colleagues have revealed what would happen if you tried anyway for a single photon. The answer is deeply strange. Attempting to cut a photon in two wouldn't produce two smaller photons, but instead conjure an infinite number of them out of thin air. Okay, so they mean cutting a photon in two, like with a knife? Yeah, okay, they mean literally cutting it in two. Okay, this is much less surprising. The point is it would take okay, so they say that rather than producing one photon on one side and a vacuum on the other, the shutter generates something far more strange and complex, a superposition of states containing infinitely many photons simultaneously. Okay, so they're saying that part of the, yeah, so you would get a superposition, which is exactly what you'd expect because the Fourier decomposition will have a discontinuity in it. And so I guess what they're saying is that the Fourier component of each of the wave modes, or each of the photon states has a non-zero number in it. It's probably just a limiting procedure. So this is not a big deal. This is not a big thing. It is made up. It's a theory. You cannot split a photon. What you describe is quasi-equivalent. Yeah. Okay. I mean, it seems like it might be an interesting article to read, but it's probably it's probably really bad. This theory hints at confirming a state before the Big Bang of a single massless unscaled photon could be bound in a non-vacuum, non-dimensionally existent space where energy cannot travel. This sounds not real. I doubt the original paper says that at all. Let's pull it up, shall we? It is an interesting article to read. It probably is really bad. A book and cover. What? I don't know what that means. Thank you for following, Corky Cottage and Alex Soul. Let's see if I can find the paper online. Should be in the archive. Here we go. What do they say? In elementary particles such as a photon cannot be cut into two pieces. Still, it must be possible to truncate a photon with an optical shutter. The result is neither another photon nor a mix of photon in a vacuum. Instead, it is a superposition and mix of photon numbers up to infinity. This state is rather complicated and nevertheless locally equivalent to a single photon or a vacuum to the left and right, respectively, of a narrow transition region. Okay, let's just go look at what the output actually is. Yeah. Okay. So they're. I'm just looking at this paper really quick because they should have the results somewhere. To ensure negligible. Okay, so this is a long paper for PRL. Sorry, I'll answer the questions in just a minute. Oh, it's supplementary material. Yeah, okay. They don't say anything in particular. I'd have to go read it a little bit more carefully to see the infinite photon claim, because they don't display the result particularly succinctly. Okay, I'll just take a look at it later. From FF9S6B2 with the $5, is spacetime a real thing? Can you explain what people mean when they say that it may not be fundamental? So, look, so spacetime is either. Okay, this is a philosophical question, perhaps, but in general relativity, spacetime is a thing. It's like a thing that's dynamical. It has laws. It has equations of motion. It interacts with and influences things, and things can influence it. Now the question is that a fundamental thing? And by the way, by thing, it doesn't mean that it's like an object that you can hold in your hand. It means that like it is a thing with physical properties. In the same way that like the electromagnetic field is a thing with physical properties. The electromagnetic field you can't hold in your hand. It's not at a place, but it is still a thing in that it has properties that are measurable and can interact with things and so on. So the space-time in that sense is a thing. Now, whether or not it's fundamental is a different story. If it's what that means is that like, is there something that is kind of at a lower level, which in a certain limit looks like space-time? Like when you zoom out, it looks like space-time should look, or is it like is space-time kind of smooth the whole way down? That's roughly the question. Okay, let us bring up Zeno, who probably has a question. Zeno, what you got for me?
Hey, what's up, Blitz? So starting my first year as a physics and math major, but I want to self-study Griffith's electrodynamics. I know like Calculus 2 integration. Book. Yeah, I've heard. I know Calculus 2 integration techniques, all of Calculus 1. I'm doing like the beginning of Calculus 3, but like to help with the vector stuff. But am I ready for it? What else should I add to like my self-study of mathematics in order to
If you're
like jump
taking
into
Calc
it?
3 right now, you should be able to get through. I mean, so, okay, to be clear, Griffith's E&M is going to involve some vector calculus, but not a lot, and you probably have seen most of it by now, or you will have seen most of it by the time that you get to the places where you would need it, if you're just self-studying. I mean, look, it'd be great if you had all of Calc 3 before you did E&M, but the reality is you probably don't need all of it, right?
Okay,
There's going to be some stuff that you'll learn in Calc 3 that you won't end up needing. You will need to know things like the divergence of a vector field or the curl of a vector field, or how to integrate vectors or how to do line integrals and all these things. But you do learn those pretty early in a Calc 3 course anyway. So
Right.
I would, if it's for self-study, just give it a shot. And if something gets confusing, hold off, or go look at your Calc 3 textbook and try to learn it, and then keep going. Like there's no harm in, because you're gonna have to take a class on E&M anyway, so
Right.
you're going to be seeing it again, and having seen it the first time, kind of in a self-study sense, could probably help.
Okay, cool. What about anything from DiffEq? Will I need like any?
You won't need that for E&M, no.
Okay, cool. There was another question. I know last time, like I briefly mentioned like something about quantum mechanics, like interfere or causing issues for like hard determinists.
Sure.
Then my friend told me like about pilot wave theory and how that
Yep.
might be deterministic. So like, what's the clash there?
So pilot wave, if you take pilot wave theory, Bohmian mechanics, or what else do they call it? Bohm-de Broglie theory. All these things are the same, but it is purely deterministic. The catch is that you don't know what the initial configuration of particles is, so it's still not detectable. Like it still behaves exactly as if it's stochastic, exactly as if it's non-deterministic, but the underlying mechanism is purely deterministic.
Okay. That clears things up. Okay. Well, I mean that's pretty much all I had. But I did want to thank you. You're part of the reason why this summer I like started doing a lot of self-studying, like watching your streams with like Matt, even though Matt can be Matthew Davis can be kind of
Yeah. He's a character. I think that, if only he was learning for the sake of learning rather than learning for the sake of making an argument, I think that he would have a lot of potential.
Right. Yeah. No. I mean, he seems super interested in this stuff. But I mean, yeah,
Yep.
it's influenced me. You're influencing people to study physics, and I love that. And
I appreciate that. All right.
Yeah,
Well,
of
thanks
course.
for being here, Zeno, and good luck.
yep. Thanks.
So wholesome. So wholesome. All right. I'm going to bring up a guest from, wait, Nightbot is becoming sentient. Nightbot is becoming sentient? What is happening? Oh no. Lilith, if you're watching, we might need to rein in Nightbot. All right, let's bring up some guests from the Discord to ask some questions. We have Adam Theist. Adam Theist, how's it going?
Oh.
You're on. You're here.
Thanks. It's nice to finally speak to you.
Likewise, yeah. So what questions you got for me?
I'd like to ask you about your views on contingency and time, as well
It's
as...
not the time or place. This is physics question space.
Okay, then in that case, what's your take on digital physics?
On digital physics? You'd have to be more specific than that. Do you just mean like the physics of like semiconductors used in digital processing, or?
No, so I mean the idea that space and time is discrete.
Oh, I'm pretty agnostic on it. I think it's an interesting idea and I think it's worth thinking about, but I'm not convinced that it's like definitely true.
Okay, and as regards particle states, so for example, sort of like the taxonomy of things like baryons and leptons, they seem to decompose into these kind of discrete states. So a positron is positively charged, electron is negatively charged. It sort of looks like you could divide the family of particles into the table of a cellular automaton. That's quite interesting.
I don't know how you get to cellular automata from the family of particles that exist, but maybe.
Okay. Well, there's this kind of idea that when you have a wave particle interference pattern,
Yep.
it's sort of like there's places where the particle is highly likely to appear and less likely to appear.
Yep.
So you've got these constructing and deconstructing patterns.
Yeah.
When a cellular automaton is patterned out, what we see is a very similar pattern in the cells. So in terms of where something appears and where it doesn't appear, which cells are filled, which cells are empty, it's sort of determined by this grid-like arrangement of columns and rows. And so if you have the columns and rows as the properties of each particle, there's a visual similarity between that and the way that space works in terms of particles.
Seems interesting, but do you have a question? Because this is like it's like a Q&A space.
All right. I think well, I didn't have any questions kind of lined up, but okay. So I've heard a few times quite a few times you've discussed this dichotomy between A theory of time and B theory of time.
Mm-hmm.
Is there an argument why I can't accept some propositions from A theory of time as well as a proposition from B theory of time? For example, like the past exists, and is there some kind of contradiction between the two?
Perhaps you could. Probably have to look into it more to make sure that they're not mutually contradictory. I mean, so the one where you have like what you're talking about is like growing block theory, where the past exists, the present exists, but the future doesn't exist, and it just seems like you could hold that position, but the reason why you get to the past, present, and future all exist in kind of the same way, like they're all equally real in B theory, or at least the reason why you get to that from relativity is because relativity, in the exact same way that a now can include somebody's past, your now could also include somebody's future. And so, it seems like you're kind of like imposing some symmetry that probably shouldn't be in there to begin with. And it also, doing that also breaks Lorentz invariance, by the way. So if you take Lorentz invariance to be a fundamental, taking just that the past and the present exist, that violates Lorentz invariance. And so if you take Lorentz invariance to be a fundamental symmetry of our universe, then you can't have that.
Okay. Is it possible to hold the position that the future exists structurally, but it has like some free variables? So my reference frame, my present can exist, and that has certain constraints on the future of another reference frame. But also I'm accepting general relativity. Is there some?
So
is there
the thing. Probably, in the sense that any general relativity, if you're getting your understanding of time from general relativity, then you really need to treat the past and the future as not like physically indistinguishable, but they need to have the same kinds of properties. So if you're going to say that the future only has like some constraints, so the future is kind of structurally there, but it's not like determined, then you should say the same thing about the past.
Yeah. Why the past?
Because GR is time symmetric. GR is time symmetric.
But time symmetry, how can that? Why would that not just apply to the structure rather than the determined and measured states?
The states are time symmetric, right? Like, of course, depending on what the initial conditions are, you can get difference between past and future if the initial conditions are directed. But like, the point is that the same underlying foundational principles that get you to in GR, that get you to thinking that my present could include somebody's past. That would mean that your present could include some states that are in somebody's past, right? But similarly, my present could include some states that are in somebody's future. And so, like, if we're accepting that someone's now could be in somebody else's future, then that includes the states, not just the structure.
Yeah, I'd agree that it includes the states. I think the contention that I'm feeling is that certain things are undetermined. Uh, what's not symmetric is what is undetermined between reference frames. So
Well, so,
I
so
haven't
to be
gathered.
clear, in GR is a deterministic theory, right? So in GR, the future is just as determined as the past. Now, you could talk about something with quantum mechanics, and you could say, oh, well, quantum mechanics might throw a wrench into that. Maybe it does. We don't really have a good understanding of what happens when you mix the two. But GR is a purely deterministic system.
Is that just because it refers to the laws? It's just talking about the invariance of the speed of light, and
No, it's because it's
isn't
classical.
that
There's no
what's
randomness in GR, right? Once you know the initial conditions, then the entire future of the system is determined.
I didn't know that GR makes claims about the kind of processes that quantum mechanics talks about.
It doesn't.
In terms of
No, so what I'm saying
But
is
then-
if we lived in a world that was purely governed by GR at all scales, then it would be purely deterministic. Now, we know that there's some tension between GR and quantum mechanics, so we probably can't say that at all scales. But at classical scales, where you and I exist, where galaxies and stars and all that stuff exists, at classical scales it is deterministic, because at classical scales, quantum mechanics gives rise to classical mechanics, and classical mechanics is deterministic.
what I'm not understanding is how do you reach that all states are deterministic in GR?
That's just
if
a
it
property
doesn't-
of the theory, right?
But why is it a property of the theory?
It's a classical field theory. Classical field theories are determined by their initial state, or the state at any future time in a classical field theory is determined by the state now, and it's essentially its momentum now. So it's determined by the conditions now. Modulo singularities can throw a wrench in this stuff, but
Listen, so when you say it's determined now, so if you have some initial momentum, that's it. You can say that's in the past, and then there's some
we'll say it's
present
now.
momentum.
Say
Well,
your
of course,
momentum is whatever your momentum is now. You have a position now. You have a momentum now. In the case of GR, it's you have a space-time. You have a spatial metric, and your spatial metric has a momentum. And then you have all of the fields or all of the objects that are in that space. They have momentum. They have a position. Once you know all of that, right now, you can exactly predict all of the future behavior of that system. Again, disregarding quantum mechanics.
I think there was equivocation there, because you said that the states in the future are going to be determined, but the initial thing you said is that what's determined is in the now.
I think that maybe we just spoke past each other. The point is that the future states can be determined by the initial states. In that, like, if you had a strong enough supercomputer, you plug in the initial states, you crank the machine, and it outputs exactly what's going to happen in the future.
Okay, but what is it about GR that allows that?
It's true for all classical theories. And GR is an example of a classical theory.
Okay, when you say classical theory, you mean theories which
are not quantum,
which stipulate that causation is local and classical?
No, just theories that aren't quantum. There are ways to talk about this in terms of symplectic geometry, but it's probably not worth going into that.
Okay, but this sounds like the assertion here that every state in the future can be determined in GR is just based on a dichotomy between GR and QM.
No, it's just a feature of the mathematical structure of the theory.
Okay. Well, okay, I'm not sure to what degree I can push back because GR and QM seem to me to be talking about different things.
Yeah, so quantum mechanics operates on a much smaller scale generally.
Okay, but what I actually meant was that GR doesn't seem to be about the determination or causation of position and momentum. It seems to be about speed and time dilation and gravitation.
No, I mean GR is like definitely like the standard. There's something called the ADM formalism in GR, which is kind of what's typically used to do GR computations and supercomputers and whatnot. And in that formalism, you specify what the initial conditions are, what the initial momentum is of those initial conditions, and then you evolve them into the future, and you get some you figure out that helps you determine, or in fact that entirely determines the future space-time, the entire structure, the entire state of the space-time that follows from that initial time slice.
Okay, I think I see the issue now. So in GR, what I would posit is that what it's talking about is general constraints, which of course is going to give us accurate predictions on a macroscopic scale. It's not that the two, of course, the constraints are deterministic. I'd agree with that. So the laws of physics are deterministic.
I don't know what you mean by it gives us general constraint. Like, the point is that with GR you can predict where a thing will be in 10 years.
Yeah, within a particular range of uncertainty, you can predict.
Well, sure, but that's the case. That's the case in, you know, even if the universe was purely classical, even if there was no quantum mechanics at all, that would be the case, and that's just because, you know, we use numerical methods to solve these equations.
Okay, but that seems to concede that GR isn't purely deterministic.
No, GR is. It's just the numerical methods that we use to make predictions are not exact.
If they're not exact, then that's because of uncertainty and indeterminism.
No, it's because of uncertainty in the inputs, really, and it's uncertainty in the way that we compute derivatives and things like that. And these are uncertainty at like the computational level, not uncertainty at like the mathematical level.
Uncertainty is a relationship between time point 1 and time point 2, given the conditions in time point 1.
No, I'm talking about like computational uncertainty. Like you have a certain amount of precision that you have. Like you have a certain amount of precision when you're computing a floating point number, for example. And say you run into those like a floating point.
Okay, I mean, I just understand. Well, I thought that what you're talking about is like statistical error, like sampling error and measurement error, things like that.
I mean, that'll feed into the initial conditions. Like you can't measure with 100% certainty, like accurately. You know, if you have a ruler, if you have a measuring stick that only marks centimeters or only marks millimeters, then you can't get down to micrometers because you just can't. Like the tick marks aren't that small. But there's also error that can accumulate from using like. You should look into like numerical integration, for example. Numerical integration techniques are like they introduce a small amount of error just because of the way that we solve these math problems, right? It's not because the math problems aren't deterministic. It's just because the way that we have to efficiently do these introduces some degree of error.
Okay, so right, you're saying that the uncertainty in GR-based computations is based on this kind of error, this kind of uncertainty.
It's like the same thing where like look, there's no uncertainty in the area or in the circumference of a circle with diameter 1 centimeter, right? It's exactly pi centimeters, right? Pi centimeters is exactly the circumference of a circle with diameter 1 centimeter. But if you went to try to compute that on a computer, it wouldn't be exactly pi. You would get something slightly different because computers don't have infinite precision.
Yeah, true. They don't have infinite precision because. And
so you would introduce some error. It's the same kind of thing happening in these kind of numerical computations of GR.
Okay, but there's an additional source of uncertainty within your 10 centimeter circle. There's all the microstates and the objects, right? That's to do
I'm just talking about like an idealized mathematical circle, right?
I'm not sure where the uncertainty there would be if it's just
the uncertainty is that if I told you that the diameter is 10 centimeter or is 1 centimeter, and I told you, okay, go get on your computer and calculate using whatever method you want, calculate the formula or give me a number that tells me what the circumference is. Well, you would go on a computer and you would, maybe you would draw little lines around the circumference or whatever, and you would make those lines really, really tiny or whatever, and you would get something very, very close to pi centimeters, but it wouldn't be exactly pi, because pi is an irrational number, and we can't represent irrational numbers in decimals or with finite decimal expansions.
Okay. Well, isn't I mean, we're kind of getting off track now, but isn't just representing pi the answer? You just represent the answer with pi.
Yeah, you could, but then if I asked you, okay, what's pi? Then you'd have, like, if you wanted to give me a number, like in Arabic numerals, in a decimal expansion, or some sort of fractional expression, whatever it is, you wouldn't be able to give it to me, right?
I'm not sure that that's a physically relevant form of uncertainty, though.
It's an analogy because I'm trying to explain what kinds of errors can show up in computers, like when you do numerical computations to solve differential equations, which is what we're talking about here in GR.
Okay. But fair enough. I don't want to keep someone else from joining. I think I'll think about this connection between GR and QM, whether or not GR is whether or not the future states can all be determined in GR, and I think I'll think about that. And
okay.
I'll try and join one of your atheism versus theism streams.
Okay, fair enough. Take care. Good luck.
Thank you.
That went longer than expected, but it's worth talking about. Like, those are interesting questions. A lot of people don't understand what it means for a thing to be deterministic. So let's read some super chats or read some comments, and then we'll bring on our next guest from TikTok. Have to wind back a little bit. I have ADHD. Can I still be smart? I have ADHD, so if you think I'm smart, then you can too. Even if we solved the fuel issue, could a human in a spaceship even survive the acceleration to near light speed? Yeah, you could. So the thing is it doesn't take a lot to get to near light speed. If you accelerated at just 10 meters per second squared, which is like the acceleration that gets us, it's the gravitational acceleration we have on Earth. Even if you just accelerated at 10 meters per second squared, you would get to near light speed within like a month. And you could obviously survive that. From FF9 with the tomato, $2, thank you so much. From Jord, I wonder how far we can reverse engineer this stimulation we live in. That is like, I don't think the world is simulated. Hey Blitz, have you ever thought much about the relationship between mass and frequency? Curious about your own thoughts and opinions. There is a relation between it, at least between momentum and frequency. But that was done by De Broglie in the early 1900s. These feel like questions to goad Blitz into a debate during our Q&A. I know. He was, but when I told him this is a Q&A, he did redirect, which I appreciate. You can only be precise in relation to a reference of scale and unit. To be more precise is to trade off scope and to focus on tunnel vision onto a portion of inquiry. It's literally about scale. That's very true. That's an interesting way of putting it. Sub-only mode indeed. Thank you, Robybert. Yeah, thinking about joining GR and QM together. Get back with me when you figure it out. Yeah, I figured that, he'll spend some time on it and realize it's hard. I don't think the world is simulated either, hence the T in stimulation. Oh, okay, then I have no idea what you mean. All right, let's bring up Jarman, a guest from TikTok. Jarman, how's it going?
Hello, Dr. Blitz.
Howdy. What questions you got for me?
I've been watching your content for a while. I like your content, man. I really do appreciate the stuff you have. I also do appreciate how I also really do appreciate how you clear up scientific blunders that people make. Because as someone who does the same thing, I can respect and resonate to people who do the same thing, especially with a doctor in mathematical physics.
So what you got for me?
I wanted to ask two questions. Number one, I want to ask about mechanics of time, so specifically with A theory, B theory, and C theory. And also wanted to ask a question about your opinion on the critiques of defining physical laws as like real, or as in like as conceptually real. So the first question I have is, so from what I've read of the A, B, and C theory of time, they all discuss the mechanics of time, but I'm not sure if any actually discuss the origins of time. So how would you approach the question of treating time as, because this is what C theory articulates, how would you approach a geometric treatment of time as proposing that time could have an origin?
I don't know how you, okay, so you could have an origin of time in the sense that there's a first moment of time, but I don't think that you can have an origin of time as in like all of time starts to exist. Like there can be a first moment of time, but it's hard to say that that's the origin of time if you're kind of viewing it from an outside perspective. I do think that time is a geometric thing in the same way that I think that space is a geometric thing.
So you're treating like blocks, like slices of time as just, how would I say, treating the future as like further into this geometric like treatment? I'm confused.
Yeah, basically.
So like different points of time would just be different slices of this same shape.
Yeah.
So how would you treat the difference between an origin of time and a first moment of time?
Well, because if I'm thinking of time as like a whole thing, then it's like all of the slices, right? And all of the slices don't really have an origin, because they are all of the possible times when a thing could happen. There's no time when a thing could originate outside of the times, because that's all of the possible times. Now there could be a first moment, because time, at least in sufficiently nice space-times, is ordered. So there's a notion between past, present, and future, or there's a notion between past and future, I should say. There's an order. And so you could just ask, what's the past most moment of time? And then that would be a totally reasonable way that you could talk about like a first moment of time. But it doesn't mean that like that moment of time existed before, or that moment of time existed when all of the other moments of time didn't exist. It's just that moment of time was just the earliest one. But in a B theory, at least in a B theory kind of geometric view, they all exist. It's just some of them are earlier and some of them are later, but they all exist.
Yeah, but the B theory is still geometric. So you're basically saying that within the earliest, it's basically the past of the past, it still exists within that time block, right?
Yeah.
And the first moment would just be the first slice of the time block.
Yeah.
Oh, okay, that answers my question. Thank you. I was really confused as how to approach that. Now, the second one is, how would you feel about? So I was reading up, I was having a discussion about this. I was reading about a critique on defining physical laws as like scientifically valid, because within the argument this was posed as, they said that laws are basically just suppressions of alternative states. But
Laws are just what now?
Laws are suppressions of alternative states.
Laws are suppressions of alternative states? Okay, go ahead.
So, but we know that, for example, if we like use electrostatic repulsion as an example, right? And we obviously can observe electrons repelling other electrons.
Sure.
We can't say that there's alternative states present, because it's in an electron's intrinsic nature to repel other electrons. So how would an alternative
that's under
state
one view.
It's under one view?
Yeah, so one view is that one view of the nature of physical laws, and by the way, this is getting deeper into philosophy than it is physics, but one nature of the view of physical laws is that they are mere descriptions of dispositions. And so under that view, there is like this intrinsic disposition of electrons to move away or to be repelled by other electrons. And then the physical laws are just a description of that disposition, that tendency. And so in that sense, the physical laws perhaps are not like things that have ontology themselves, but they are describing properties that are actually real. Another view, though, is that physical laws are merely like a very compact way of packaging an otherwise kind of unrelated sequence of events. Like it's just kind of like a compression algorithm, if you will, for the sequence of events that make up our universe. And the physical laws just kind of give us a way of compressing that data. Whereas there's not actually anything there's no like dispositions, there's no reasons why things are the way they are. They just are a certain way, and then we package that in a compact way. That's another view. And so, the second view I gave is kind of Hume's view, which is a fairly old view, but it's not so unpopular. But yeah, I mean, I guess, and in some sense, you could view the latter as kind of being a suppression of the other ways it could have been, because the idea is merely that the universe is a certain way, and so we just we kind of compress that information into a smaller state and say that this is the only way it could have been, because it is that way. But, there are a bunch of different ideas about what physical laws actually are, like what kind of status they have.
So the second view, so just before I understand, when you define disposition, you're talking about like in relation to something avoiding a certain thing,
or being attracted to a certain thing. It's just like a tendency for a thing to behave a certain way.
Oh, a tendency for something to behave in a certain way.
Yeah.
Okay. So in this definition, you're talking about like essentially laws being summarizations of what we understand these algorithms to carry out. Right.
That in the former situation, yes. In the former the former depiction of what laws are.
Oh, so is this like, what's it called? The like distribution theory? like kind of like just understanding different ways in
I
which.
haven't heard that phrase used to describe this.
No, but what I mean by
Go
that
ahead.
is like, what I mean by that is like, basically understanding different modes of these like algorithms being implemented in different scenarios, then compacted to understand like overall what's the overall trend you notice.
No, not really, and it's not even really algorithms. It's just that like there are these objects that have a certain disposition to do certain things, and so the physical laws are just descriptions of that. Think of like think of I don't know, some law of chemistry or something where if you have a high pressure, or if you have a high partial pressure solution, like you have lots of salt in one area and then there's a porous membrane and then not a lot of salt on the other side of the porous membrane, the salt has a tendency to go across the membrane and equalize. And so we would say, okay, well, there's this disposition for fluids containing salt to do this thing. This is a thing that happens, and we see it happen, and that's like a natural property of the things. And then we write down like a formula that describes it. And so that's what the law is. The law would be the formula.
Okay, so the law is okay. That makes perfect sense, right? That makes perfect sense. So instead of, because when I, as you noticed with my definition of law, I was talking about the physical, but you're talking about like essentially description of the physical instead. Because I was going
a law
strictly.
is a formula, right? Or it's a formula or a family of formulas or whatever. A law is a mathematical thing. Now, whether those mathematical things are capturing like actually exist depends on what your view on mathematics is. But regardless of your view on mathematics, you can hold the view that those mathematical descriptions are either descriptions of something that's actually there, some natural disposition, or they could be descriptions of just kind of like, or they could just be like a kind of a compressed description of the sum total state of affairs of the universe, even though there's no actual kind of causal explanation for why the universe is in that state of affairs.
Perfect. And state of affairs is just the description of the physical reality, right?
Yeah.
Perfect. Can I ask one more question? Because I
Sure.
just remember there's one more question. I remember there was a video you posted about why the universe cannot be simulated. And I remember the reason why was because the energy required for that would be way too much for it to even contain in such a universe.
Yeah.
Is that like a correct evaluation for what you were trying to articulate?
Yeah, that's right.
Is that literally the only reason why?
Why I don't think, well, I mean, I think that is a justification for why you shouldn't think that the universe is in a simulation. The other reasons that I don't think that there's good reasons to think that we are in a simulation.
Oh, okay, fair enough. Because most of the time I noticed that it's just epistemic skeptics that usually argue we're in a simulation.
Yeah, it's and unless you have a reason to actually, like, you can be epistemically skeptical, but then you need and just be like, I'm skeptical, I just don't know these things. But then to go on and say, well, it's likely that we're in a simulation, that's not a justified move.
Because again, there's no ground in which they actually understand their claim to be true. They're just assuming it from a skeptical standpoint.
Yeah.
Do you run lives talking about like Ask an Atheist, or is it just Ask a Physicist?
Just Ask a Physicist.
Is there any way I could like possibly have a discussion with you in regards to arguments for? I'm an atheist, but is there any way I could like?
You could join the Discord server. I participate occasionally, and there's like but there's plenty of other people that would also be interested in certain conversations. So like that's the place to do it.
Well, thank you very much, Dr. Blitz. Have a nice day.
Of course, take care.
Take care.
All right, let's answer some questions and we'll bring on another guest. I need to drink some water. Stipulation is that formal set of agreements and parameters and barriers. Life is a stipulation, I'd say. I don't understand what that means. Been a lot of questions about time today. Interesting to hear the conversations. Yeah, I don't know why, but that is the case. From Mauritius, thank you for the message that you sent in sub-only mode. How could torsion caused by spin prevent singularities within the black hole? So the idea is merely that the torsion contributes to the dynamics of a system, and it happens to contribute in a sort of repulsive way. And you could work out the details, and I think it was Ashtekar that worked this out first, maybe in the 80s, that showed that the net consequence of including torsion in Einstein-Cartan theory, of including torsion in your computations is that there is a maximum density that is allowed. The repulsive force from the torsion, which is, produced by fermions, in Einstein-Cartan theory anyway. Actually, I'm sorry, this is loop quantum gravity, but you can also see this in Einstein-Cartan theory. The repulsive force, it wasn't Ashtekar. The repulsive force produced by fermions, which have spin and thus interact with torsion in Einstein-Cartan theory, diverges once you get to a certain, as you approach zero size, and so you would reach a balancing act. You would never actually get to singularity. Kind of the tendency to collapse and the tendency to be repelled balance at a certain point. And this just falls out of the mathematics. I think it was, who was responsible for this? I want to say it was a Polish physicist. A famous Polish physicist, even. Popławski, rather. Oh no, is it Popławski? It was someone. And my Polish friend is going to hate me for this because I can't remember his name. Yeah, it wasn't Popławski though. I don't think. Popławski wrote some other stuff on it, but no, there's a really, it was Trautmann. Trautmann, who did a lot of work on Einstein-Cartan theory, which is where this torsion idea comes from. From Genus Official with the $10, thank you so much, bud. Silly question. If you invented a new fictional fundamental field enabling powers like flight and telekinesis, what properties would you give it to make it feel scientifically consistent or plausible? I don't know, it's really hard, right? It would have to interact with the electromagnetic force, otherwise you couldn't, push things or pull things. So it would have to, in some sense, be charged. I don't know. Maybe like a magneton field, which would be like a magnetic monopole that you could control. If you could control magnetic monopoles, you could probably have flight and telekinesis, I imagine. If you could produce them willy-nilly. I don't know. It's a fun question though. Yeah, I wasn't thinking of Popławski. Popławski has done a lot of stuff on it, but I was thinking of Trautmann, actually. You cannot be both trout and man. This is madness. Now I think the Earth is flat. True. It is impossible. It is impossible to be Trautmann. Let's talk to Noah is back. Oh, actually, I should have brought on a guest from Discord. Okay, I'll bring on a guest from Discord next, after Noah is back. Noah's back. How's it going?
Yeah, how's it going, dude?
I'm doing all right. Noah, what questions you got for me?
Yeah, so I'm going to my, sorry, let me close my door real quick. I'm going to college in about 2 weeks. I'm going for astrophysics and dual major in aerospace engineering.
Okay.
And so I'm not very, I watch your lives and I feel like I'm blown out of the water intellectually. And so
I'm also 15 years older than you, so
yeah, I guess that's the question. Is what kind of advice do you have, as someone who's far more experienced?
So I don't know anything about any sort of engineering degrees. I never took any, so I can't comment on that. But at least as far as the physics degree or an astrophysics degree, if astrophysics degree is going to be very similar. One of the things that was the stumbling block for most of my classmates when they did stumble, not all of them did, but when they did stumble, the biggest stumbling block was that they were still struggling to understand the mathematics that was being used in the physics class. So for example, this would be like taking an electromagnetism class while simultaneously taking a vector calculus class. Electromagnetism is fundamentally based on vector calculus. So if you're just learning vector calculus for the first time, you're going to struggle to understand what's even happening in an electromagnetism class because you don't have the mathematical toolkit to understand it. So probably the most important thing that you can do is make sure that you are comfortable with the mathematics that are involved in a class before you take the class. A lot of times these classes will say, oh, there's a co-requisite of XYZ, and like that's true, you could probably get away with it, but you will spend a lot more time trying to just follow the math that happens in lectures, for example, than you will trying to understand the physics material. So, you know, if I was to give one piece of advice, it would be to make sure that you shore up on your math, whatever math is necessary for a class, before you take that class. And that's probably true in engineering as well.
Yeah, so like I think that's great because like it's also kind of like I felt like I thought of that because like so for me like I haven't taken any sort of calculus.
Mm-hmm.
I did algebraic AP physics just this year, past year I guess. But I'm going into calculus based physics and I'm taking calculus at the same time, and so like I kind of felt like, oh, it'd probably be better if I get up on this little ahead, right, catch up a little ahead. And so I decided I started to use like Khan Academy and tried to like use just get some fundamentals like limits and everything like that. And I guess is that like a good idea? Would you say
it is the best thing that you could be doing. I mean, the second best thing that you could be doing, and it's too late for this now. And I'm not saying do this, but if you wanted to be extra conservative, what you would do is you would wait like a quarter or wait a semester before taking the calculus-based physics class, so that you could have a semester of calculus under your belt. But if you're at least getting familiar with these calculus ideas now, then that will help. Keep in mind, you will need to do that for the next year or so as you take your calculus-based physics courses, your intro ones, because the math that's used in the higher calculus-based physics classes also increases. Like I said, electromagnetism is fundamentally a vector calculus-based class, and people will take that at the same time that they take electromagnetism, and that will hurt you in the long run if you're learning both simultaneously, because the math is not the point of the lecture, right? When you go to a physics lecture, you're going to see a lot of mathematics written on the board, a lot of formulas, some derivations sometimes. The point is not that you're supposed to be learning how to do the derivation. I mean, that's important, but the point is that you're supposed to be understanding the derivation so you can understand what the physics is afterwards. And if you're struggling to understand the derivation because your math isn't as strong, because you haven't taken as many classes, you will struggle. Also, go to office hours. That's also the second most important thing that you can do. Go to office hours. Yeah, go to office hours. Go to your TA's office hours. Go to your professor's office hours. Ask questions. If you don't get something, and like, be like me, be the annoying kid at the front of the class who just asks questions whenever he has a question. The professor will not be annoyed at you. Okay, if you do it too much, the professor will be annoyed at you. But if you do it at all, the professor will like you, because they'll be like, oh, this person's actually paying attention and wants to learn rather than just wants to, whatever. So asking questions is a good thing at office hours or in class. Just, all good things.
All right, cool. I think that's really it. I guess I just what would you say is like the so like I kind of have I guess another like problem I need help solving is like I kind of have a hard time like whenever I have like a problem, when I'm trying to solve a problem, I have a hard time like applying the math to a conceptual idea. Like it takes me about a week or a couple weeks or two in order to understand like simple things like even some fundamental aspects of division and like how like I remember I took a while for me to understand how I haven't even fully grasped how for example like this, and as you increase your speed, like the time difference that it takes for you to travel one point to another is minimal as you increase your speed.
Yeah. That is just fundamentally unintuitive. Like I don't know anybody who like that's intuitive for, because like there are a lot of people who can just do that math in their head very quickly, but it doesn't mean it's intuitive. So I wouldn't worry too much about that. One thing that you will find is that the application of mathematics to solve physics problems, that's the kind of thing that you're going to be learning in a first course on physics class. And so this is why I say make sure your math skills are good, because once your math skills are good, you don't have to learn how to do the math, you just have to learn how to use the math. And that's a very different task, and it's arguably a lot easier than learning how to do both at the same time.
All right. Well, that's great. I really appreciate this, Dr. Blitz. Thank you so
Yeah,
much.
of course. Good luck.
All right,
Let me know how it
have a
goes.
nice-
Take care.
I will.
One of the things that it's like super satisfying, and I've had this happen several times since I've been doing social media stuff, and even like when I was teaching as a grad student, like I've had students, whether they were my students or just students that they liked what I did when they were in high school, and so then they went to physics college or went to university for physics or whatever. When people like email me or message me on Discord or message me on TikTok, be like, hey, because of you, I took this class, and I studied, and then I got this grade, and I'm really proud of it, and thank you. Like that is like the best thing that you like. That it's like it's all worth it, right? Like all of the flat earthers, all of the woo-woo nonsense people that I deal with, it's all worth it for that. Like honestly, best thing. All right, let's bring up a guest from. Oh, let's make sure I read some questions, and then I'll bring up a guest. Best advice for people learning physics is you never stop learning even after death. Okay, this seems like it's not real advice. Hard math majors and hard math heads are more likely to commit suicide than non-mathy people. The ideas are so abstract, so look after yourself. Well, that may be true. I don't know if that's true. All right, let's bring up a guest from Discord. Let's bring up I Got Zelda. I Got Zelda, you were on the live. Please let me know what questions you got for me. You also have to unmute yourself, by the way.
My bad. Appreciate your stream, man.
I appreciate you.
I was watching, what was it? I think it was Neil deGrasse Tyson. He was talking about force carriers and stuff, which gave me a few questions.
Yeah, sure. Fire away.
So I think it was him. I watched so many videos. He was saying, so the photon is the carrier for electromagnetism. What gluons would be carriers for the strong force.
Yep.
Is that still correct? Okay. So then it made me think about gravity and gravitons, and I'm looking at the standard model, see W and Z boson. So I'm like, all right, one of those must actually just be graviton. But then I see there are two carriers for the weak force.
Yep.
I don't understand that.
Well, okay. So what's happening is that the weak force has. So the electromagnetic force has one charge, the weak force has two charges, and the strong nuclear force has three charges. The electromagnetic force charge that you're familiar with is, there's plus charge and there's minus charge. That's like one charge, and then it's just like it and its opposite. That's like one thing. The strong nuclear force has three charges. It has, we call it red, green, and blue. These are called color charges. And so there's red, there's anti-red, which is kind of like plus and minus. There's green, there's anti-green, which is again like plus and minus, but different. And there's blue and anti-blue. And the point is in those cases, you have three different kinds of charges. And gluons have that charge. They talk to things that have those charges, and they carry some of that charge themselves. The thing is the way that we got the weak force and the way that we got electromagnetism was via a fairly complicated process called spontaneous symmetry breaking. And so the weak force does have two charges. It's just those two charges are kind of split up between two different kinds of particles. And so, electromagnetism has one, the weak nuclear force has two, and the strong nuclear force has three. It's because of this spontaneous symmetry breaking happened that, unlike for the gluon, where the gluon, even though it has three charges, the gluons technically have eight charges because there's.
Oh, can I ask something real fast?
Yeah, sure.
So these charges for the other forces, are they similar to the gluons with like 1/3 and 2/3 charges and things like that, or is
those are the quarks? So
that's what I meant. I'm sorry.
Yeah. So the sort of, I mean, like the point is that a quark has a plus 2/3 or a minus 1/3 electric charge, but quarks also have color charge. They will have either green charge or an anti-blue charge or whatever. They will have one of the color charges. Gluons also carry color charges. They carry a color charge and a different anti-color charge, so they can kind of change the color charge of a quark when they interact with it. So think of like a gluon that has blue and anti-red, and it goes and it's absorbed by a red gluon or a red quark. Well, it had blue and anti-red, so the red and anti-red cancel out, and so the quark is left with blue.
Okay.
But anyway, this is all to say, yes, the weak nuclear force does have two different charges. It's just they live on two different kinds of particles because of the way the force kind of split off from the electromagnetic force.
And we don't know what caused the symmetry breaking?
Oh, we do. No, this is the Higgs mechanism.
We do?
It's the
Okay.
Higgs, that's the whole reason why the Higgs mechanism exists.
Yeah.
Well, it's part of the reason anyway.
Okay, and then I guess that would lead me to, what does that lead me to? I'm also curious about the graviton, and then
Sure.
like, so if say we do the experiment, and we either definitively see or don't see, the graviton, will that give us anything to, merge, quantum and classic, or do we not know, or
So if hypothetically we devised a machine and we built and detected a graviton, then almost certainly that machine would be the kind of machine that could tell us what's going on with quantum mechanics and gravity.
Mm-hmm.
Like almost certainly.
And essentially that's just a more energetic particle accelerator?
Yeah, I've seen estimates that it would have to be like, so, with current magnetic fields, or with current, we use magnets to, make the particles go around in the circle, right? Before they smash together to accelerate them.
Thousands of times more energy or something, probably.
So, yeah, you would need like a particle accelerator that's as big as the solar system.
Oh, gee.
Yeah.
Right.
Unless we have some huge breakthrough in magnets or some huge breakthrough in like being able to accelerate them in like a smaller distance, then it's probably not feasible.
Or, oh my God, or what we got? No, you'd have to catch just random particles out in space and see it. That's crazy.
Hope. Yep.
Oh my God. Okay. Then I have a fun question if
Sure.
there's still time.
Yeah. Go ahead.
I know you don't like the simulation theory and stuff, but as just a nerd, I always thought you could tell me why all this is wrong. But I was always like, okay, well, RNG, that can be, Heisenberg uncertainty. Speed of light could be, rendering issues and like that. And so, why am I wrong about that?
Well,
And then
it's
that
like these are all good analogies, but like unless we have reason to think that it's real, why would we? The reason I say this is so we live in the information age. How old are you? You sound like you're like 25, 35, something like there.
I'm in my 40s.
Okay,
40s.
Well, great. You sound young. That's a good thing. I meant your voice, not like the questions that you were asking.
Okay.
By the way, so like, look, you grew up. I have a friend who's turning 50 in a week, and he grew up playing video games. I'm sure that you did too.
Oh yeah.
Or maybe you were an outside kid. Who knows?
From the beginning, man. Atari all the way through.
Yeah. So I mean, yeah, from your name, right? So like we grew up in this environment where like we're surrounded by like technology and simulations and stuff like that. So like the natural thing that we want to draw an analogy to is like, hey, our universe is kind of like that. But if you went and you asked people 150 years ago, their brand new technology that was taking over the world was clockwork. And you see all of these descriptions about how the universe is just, it's a big clock mechanism, right? So I think the whole simulation thing, I think it's really just a symptom of the fact that we live in the information age, that we think that it's reasonable. Because it's just a matter of the fact that that is like the dominant feature of our lives is digital technology, in the same way that the dominant feature of the lives of people living during the Industrial Revolution was like mechanical machines, right? So I don't know. I'm just not convinced, and unless somebody gives me evidence, I'm going to be like, I don't got it. But it's definitely fun to think about.
I believe it. Yeah, I like to know why, why I'm wrong, or
if those questions, if those thoughts make you wonder why, that's good. I think it's good to ask why. I think it's bad to ask why and then be like, it's because we're in a simulation. That's the answer.
Oh yeah. The main reason, a lot of stuff. I'm probably wrong about the way I'm understanding this too. Is a lot of stuff. Other than quantum, it seems almost comes down to being digital as well, and I get confused with quantum, 1, 0, or both. So that throws my whole thing out the window. But
sure,
I think that might be also why people might probably wrong.
I mean,
so
like,
if I'm wrong, please explain that.
It's easy to draw analogies between the things that we're familiar with and the things that we're unfamiliar with, and I totally get it. I would just advise caution to make sure that the analogies you're drawing aren't based on pop science, but are based on the actual physics underlying it. Because like people actually do think about this, like error correcting codes and string theory and all of this stuff. But it's not the same as just like, Heisenberg uncertainty is finite precision. Like it's not the same thing.
Jim Gates, right?
Yep.
Is that what he was talking about?
By
Yeah.
the way,
I watch a bunch of people, so I forget. Like, I forget.
Yeah. The thing about James Gates, is it Jim or does he go by Jim?
James, I think it's
So,
names or whatever. I don't believe, necessarily. I just know he said it. I'm not saying.
Sure.
I agree with
Yeah.
him. He's right. You're wrong.
It's a funny thing about it because he
I
had
always
this
thought that
TED
was
talk, right?
a stretch too, but
Yeah, it
also.
is. So he gave this TED talk where he's like, yeah, like we see computer code and the physics. Like, first of all, he's talking about string theory, right? He's talking about string theory, which hasn't been proven. He's a string theorist. The second of all, the paper that he was referring to, and this I just find this like very funny. The paper that he was referring to, you can go find do you know what Quora is? Like Quora.com?
Yeah, the thing that always wants me to sign up, and I'm not going.
Yeah, it's horrible. But so somebody, I don't know, 10 years ago, asked a question. Dr. James Gates says that we live in a simulation and that's in the laws of physics. Is this true? And then James Gates's co-author on the paper that Gates was referring to said, no, I don't know why he's spreading this stuff. This is this is not proof that we're in a simulation.
Yeah.
So even his own co-author is like, yeah, he's being a little bit loony.
I never took it as proof. I just thought it was interesting,
Yeah, it's unfortunate because a lot of people do take it as proof, and I find that, he definitely oversold his work.
Sure. Yeah, well, I guess that's probably all I got. Maybe I can catch another stream when I get more questions. I was waiting, man. You weren't live streaming for like almost a month. I'm like,
I know,
what happened?
well, it
But
was like 2 weeks, but yeah, I was out of town.
yeah, I saw you uploading shorts, so I'm like, okay, he's fine. I just gotta be patient.
Yeah. It's just if I only have a laptop, I can't really do a live stream. So
yeah.
All right. Well,
I
thanks for being
appreciate
here,
it,
Zelda.
man. All right, take it easy.
Care. What a chill guy. It felt like a month. I know. Are you concerned with AI will take over all aspects of your job? No, not really. I mean, maybe I should be, but I'm not. I can't understand the distinction between determinism and superdeterminism. Seems like the addition of everything is determined, including the choices of experimenters, should already be a given with determinism. Can you help? I struggle with the same issue, but I think the point of superdeterminism is that superdeterminism implies that there's not even any quantum uncertainty. Like, even if you, like, the idea is that something like, it just happens to be that the outcomes we get from quantum mechanics look like they're random because of just the way that the universe happened to be 13.8 billion years ago, right? And so that's roughly the idea. It's like, it's more than determinism. It's that determinism is such that it looks like it's random. At least that's my understanding, but I don't have a great understanding of it either. It felt like a month. Yeah, sorry about that. Exaggeration and potency of the notion of determinism. Each law of physics has different degrees of determination. Well, that's not really true. We're just spoiled getting live streams like 5 to 6 days a week. Yeah, I know. My wife is upset that well, she's not upset. She appreciates what I do and how I help support her. But it is a lot. So hydration check. All right, hydration check. Let's do it. All right, let's bring up a guest from TikTok. Frederick Steinfels, how's it going?
Yes, hi. Can you hear me?
I can. What questions you got for me?
Hi. I'm from Switzerland. I'm following your podcasts, and with some things I agree, with others not.
Sure, that's fine.
I wanted to ask you, what do you think is the scientific way or the scientific method?
I take the scientific method to be, it's not like a rigid thing. I think it's that you make some sort of observation that makes you ask a question. Maybe the observation is internal, maybe it's external, whatever it is. You ask some sort of question, you want to understand how something works, so you propose an explanation, and then you work out the details of what that explanation, if it's true, would imply, and then you go run an experiment or make some more observations to check whether those implications come true. That's pretty basic.
Yeah, most of the things you're saying, I very appreciate the way you're arguing. There are sometimes I think you're not following the scientific way.
The scientific method isn't the only way of coming to true. The scientific method is only true for empiricism, right? It's only useful for empirical claims.
Okay, Yeah, because sometimes you're claiming there to be a scientific consensus.
Yep.
And in some of the cases, I do disagree. And I think you're using the scientific consensus circular logic to argue your personal opinions, mostly in political discussions.
Well, look, my point is, and this is not really the place to do like tone policing, but the point is I'm not saying you should think it's. I'm not saying that it is true because the scientific consensus says it's true. I'm saying that you should probably think it's true if the scientific consensus says it's true.
Yeah.
And that's just because that's good epistemology.
Yeah. One discussion was about global warming. So you argue that global warming must be true because there's claimed consensus.
No,
or you
I argue that you should think it's true because there is consensus. I.e., unless you're a climate scientist yourself, you're probably not equipped to evaluate the data personally. And so
no, I'm not.
The best epistemology, the best route that you could have, sorry, the most likely, the way to be most likely to be correct is to instead just go with whatever the scientific consensus is, because they're more likely to be correct than you are. So that's a good reason to believe that it's true. Now we could look at the data. We could look at the data ourselves if we wanted to, and I have spent some time looking at the data. But if we're not equipped to evaluate the data, the full set of the data critically, then relying on scientific consensus is totally reasonable and in fact probably optimal.
Yeah. So let's assume there is really a scientific consensus on that. But wouldn't the scientific method be to always use critique and try to figure out if there's... Yeah.
But not everybody's a climate scientist, and so it's not appropriate to do the scientific method if you're not a climate scientist regarding the climate, right? You just don't know enough. You don't know the full context of all of the data. You don't know what all of the standard methods. You don't know why all of the standard methods work. Why non-standard methods don't work. You don't know enough.
That's true. That's true. However, there are some very interesting sciences out there that I like to indulge myself when you talk about them. And climate science is some sort of there's no goal. Even if we do that science, it won't resolve anything. So for me, that science is not
goal
really
oriented.
interesting.
Science is knowledge oriented. You might not think it's interesting, but the point is
okay. Let's assume that knowledge is goal.
Yeah. I think that's totally reasonable.
Yeah. So, for example, I'm very much into molten salt reactors.
Cool.
Have you heard of them?
Yeah, I have.
Okay. So, putting money into molten salt reactors is science for me.
No,
money...
It can be. It can also be engineering.
Yeah, true. But I think it's a good thing to do.
I would agree.
Yeah.
But by the way, today is not a debate live, right?
True. Yeah.
So like this is not. It's probably not the place. If you have questions about physics, I'm happy to answer. If you have some philosophical questions, I'm happy to answer. But it's not the place for the debate.
Yeah. True. Let me phrase it so that is a useful question. So you know about molten salt reactors. You know that Trump has just been giving money to that. Would you sometimes you claim Trump is non-scientific, but I'm from Switzerland and look what he's doing, and I would say there's a lot of things he's supporting, and I do not have this extreme conclusion as you have. What would you do if you were president? Where would you put the money?
I would probably keep the NSF fund, the NSF equally well funded. I probably wouldn't try to cut the National Science Foundation's funding in half. I probably wouldn't try to make what grants we decide to fund political. I probably wouldn't try to cut all of our investigations into. I would basically not change anything from 2024 in the United States regarding the scientific, the state of scientific investigation. Now, we could perhaps add more funding to some things. I don't have a problem with that. I think that that giving more funding to things is a good thing. But I don't think that cutting funding is particularly the right move.
Well, I think reconsidering your funding and setting priorities might be a good idea. Where would you put your funding? Would you put it into fusion reactors or molten salt reactors?
I'm not a nuclear. I'm not a nuclear physicist. I'm pretty sure that molten salt reactors are. Molten salt reactors are fission reactors, I guess. I'm not a nuclear physicist, so I would probably go talk to nuclear physicists to get their view on like which one is most likely to produce benefits in the future.
Another question: what do you think about the UAP reverse engineering and disclosure that has been pushed under Trump? Do you think?
I don't think that any disclosure has happened until they provide us with a body
debatable.
Or with an actual, or until they provide us with a body or an actual like crashed spacecraft. I don't buy any of it.
Okay. Yeah. Fair enough. Thank you for your time.
Of course. Thanks for being here, Frederick. Take care.
Thank you. Bye.
By the way, just because I was interested, I looked up how the annual temperatures have changed over the last 150 years in Switzerland, and like it's not good. Like Switzerland has had a bad time. I was just curious though, so All right. Just want to make sure I didn't miss any questions. You versus physics does make it sound like a debate stream, that little verse right there. Well, yeah, but you're versus physics, not physicist, right? From Xenolots with the $5, why B theory of time must be sequential versus RNG or reverse? How connected to solipsism versus Brandon Avad is it? Like, must it assert realness of reality? I mean, like, B theory of time assumes that reality already exists, right? I mean, of course reality exists. But in B theory of time, like if you take the relativistic point of view, then yeah, they're sequential in the sense that they're connected. Like there is a causal ordering. The number of paragraphs I've erased regarding outsiders having opinions on Trump, yeah, fair. The correct answer was both. Fund research for both reactors. Yeah, I mean, like, there is a situation where, like you can imagine you have a situation where you have, $1 million, and you have to figure out how you want to distribute that money between fusion reactors and molten salt reactors, and that's like a financial question. So you have to like go and you have to investigate like which is most likely to give the results that we want, and you talk to experts on this, and then you figure out a way to distribute the money. I can't fight physics. It makes the rules. It's literally, it's not cheating to make the rules. It's just being in control. It's being a dom. Okay, Lord Mirak, thank you for joining. Welcome, welcome. I don't know why I didn't see that earlier, but thank you so much. I appreciate you being here. Did I miss any other people joining? All right, let's bring up a guest from Discord. Let's bring up KK Ron. KK Ron, you are on the show. Oh, okay. KK Ron is gone. Okay, let's bring up Will. Will, you're on the show.
Hey, so I wanted to ask about, so usually the Higgs mechanism is described with the like classical spontaneous symmetry mechanism math. But I was looking at alternative ways to formulate the Higgs mechanism, and one of the problems with the like traditional way it's formulated is you can't fully gauge fix it because of the Gribov
Yeah.
ambiguity.
Yep.
Why is it a problem that you can't fully gauge fix a theory?
Well, wait a minute. So to be clear, the Gribov ambiguity just means that there is in some sense, like, if I remember correctly, because I last looked at this like a few years ago, but the Gribov ambiguity is just about how even with integrated gauge fixing conditions, you can't uniquely find a gauge that is like a global minimizer of whatever your gauge fixing condition is. But that's just saying that there's not like a, as far as I can tell, that's saying that there's not like a clean way or like a clean, nice, elegant mathematical way to do this. But it doesn't mean that you can't just pick a gauge and do it, right?
Yeah, I guess there's a few people I've seen use the non-gauge fixing like reason, the non inability to not
But
be
also,
able to.
wait a minute, the Higgs field isn't even a gauge field, so like it doesn't seem like it's the kind of thing that you would gauge fix, or that you need to gauge fix.
Yeah. So it's talking about the gauge fixing of the SU cross
SU2 cross U1. Okay.
Yeah. It's talking about the gauge fixing on that, not the.
Okay. Yeah, I'm not familiar with the. I mean, I guess I haven't looked into this. So generally, you can gauge fix U1 because it's abelian.
Yes,
and you run into problems gauge fixing non-abelian groups because of things like Uhlenbeck has a result on this, and then there's the Gribov ambiguity. Now, I guess. Yeah, I don't know. I haven't looked into it. I haven't looked into what problems that would introduce to gauge fixing the SU2 cross U1. I don't know what consequences it would have or how people have approached it, but I'm sure it's been done.
Oh yeah. It's been done. I guess I just, after like reading about it, I just guess I wanted to hear if there was like another way to view it, or just like, hearing someone else's view. If this, I have a different question. If that's all.
Yeah, I mean, I don't have much to say on it. I haven't looked into like the way that gauge fixing is actually handled, because like generally speaking, the thing is I don't actually see a lot of like the Gribov ambiguity stuff actually coming up, except in some very specific cases, and I haven't looked into it in the case of the Electra week, so maybe it does come up there, but. It seems Gribov ambiguity always seems like it's a little bit of like a mathematical quirk, and that it doesn't actually stop people from doing physics.
Yeah.
But I could be mistaken about that. It's not like I'm not a QFT guy. Like I used the Gribov ambiguity in a classical paper that I wrote a few years ago, and that's the only reason I know it exists at all.
Okay. The other question is a question about one of the shorts you made. Specifically
sure.
About describing a singularity in terms of a geodesic ending.
Yep.
Why is that a better way to view it than the curvature of space approaching infinity? Like, what does the curvature of space or like the infinite density do not describe accurately that the termination of a geodesic does?
So you could imagine that so the whole reason why we want to be able to talk about, or the whole reason why we care about singularities to begin with, is something like we note that singularities are supposed to be places where like we lose predictability, or like we lose a feature of our theory where we can no longer talk about something and make good predictions. And so the geodesic can complete this business. That's particularly convenient because it just means that there's nothing that you can say about what happened before that. There's just like it's incomplete. Like there's the geodesic ends, and then there's just nothing after that. There's no more predictions that you can make. It's impossible.
Okay.
Whereas on the other hand, in principle, you could have like a point where the curvature goes to infinity, but still like I think that there are even there are even examples of this in modified theories of gravity, where you can have like curvature singularities, but it's completely geodesically complete everywhere. And so like you can still do physics totally fine there. It's just and you just would never be able to like hang out at the singularity because you'd be ripped to shreds anyway before you got there. But if you were there, then there would be a singularity there and whatever. So like that's why I think the geodesic incompleteness is probably a more useful definition. It also is more of it's more of a sign of the geometry breaking, that there's just like an edge. basically. Whereas like a singularity, like you can just take out, you could just like pop out the singularity if you want to. Like if there's a curvature singularity, you could just talk about all of the physics around it, and it's not necessarily a problem. You can even talk about the physics through it if you have a good like a way of doing that. And I think that some string theorists even think that there is a way to do that. So
Okay, that answers my question. That's all. Thank you.
okay, well, thanks for being here, Will. I appreciate it. All right, well, this is perfect timing because it's 4 minutes from closing time. And also, oh, my brother Pete just became a super fan. Thank you so much, my brother Pete. I do appreciate you. But it is 4 minutes from closing time, which means that we will be ending the live stream. I just want to make sure I didn't miss any questions. Yeah, let me answer just 1 or 2 questions. Make sure I didn't miss them. Annual temperature is also the sun cycle. The sun is also inducing the current earthquake activity. Always has, always will. Okay, that's okay. What is the coolest physics experiment for a non-scientist to do at home with under $200 of equipment? It's like, it's not super high tech and it's not super like advanced physics, but I always think it's fun to sit in the spinning chair and take like, you know, dumbbells and then spin really fast and then bring your dumbbells in, and through the conservation of angular momentum, you will start to spin really fast as you bring the dumbbells in while you're spinning. I think that that's a cool demo for the conservation of angular momentum. You could also in principle do the double slit experiment, not the quantum version, just the classical version, to see that light is a wave and it has an interference pattern. You could do that too, but that takes a little bit more work. All right, everybody, so I'm gonna end the live stream here. Thank you. Oh, let me make sure I didn't miss any PayPals or anything. We did. We got $5 from Grimlock for hydration donation. I almost missed it. All right, thank you guys so much for being here. Thank you guys so much for participating, for asking questions, for supporting me, and I will see you guys tomorrow for some more Ask a Physicist.